Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
All right, we're up. Well, thank you very much for being here, Andrew. Appreciate it. Why don't you tell everybody, if you would, what you do and what your credentials are?
So I'm a professor of atmospheric sciences at Texas A&M University. I'm the director of the Texas Center for Climate Studies. I've been studying climate and the atmosphere for about 30 years.
Okay, and I thank you for being here, and I brought you on here to counter this book. Steve Koonin, who was my last guest, and I'm trying to do this and balance things out. He has a very different take on what the science says about climate change than you do. So let's, I guess we should start. I know you've read the book. What do you think about his book?
Yeah, well, let me start with a little context. I think some historical context. So for decades, on a number of problems, there have been scientists who show up and say the consensus is all wrong. So it started in the 60s with tobacco. So, the evidence was very clear that smoking is bad for you. And then the scientists started showing up and saying, no, we don't really understand. There's all these problems with the science. And what the tobacco companies figured out very early is that having a scientist advance that message was much better than having a PR person. So they would go out and hire scientists to say, hey, we need you to push this message. And they went out. It was very effective. They delayed the recognition that smoking is bad for you for decades.
Have you seen the documentary Ministers of Doubt?
Merchants of Doubt.
Sorry, Merchants of
In fact,
Doubt.
I was going to say, that's a fantastic book by Naomi Oreskes and Eric Conway that really goes over this all the way into climate change, about how science is used to try to undermine policy action. And so then, fast forward to the 80s, and you have fluorocarbons and ozone depletion. And in fact, the exact same thing happens. The science was really well established, but these scientists started showing up saying the scientists have it all wrong. And in fact, the arguments they're advancing are almost exactly the same as the arguments that Dr. Koonin is advancing. If you take a Word document, you just do a global word replace, ozone depletion for climate change, you have exactly the same argument. In fact, I have a slide with a quote that I normally don't make people read a paragraph, but I think this is actually really useful. If you go to slide 52, this is from 1989, and I think, is it going to show up there?
Yes.
So this is a quote from something that was said about fluorocarbons. It just says, the current situation can be fairly summarized as following. The CFC ozone theory is quite incomplete and cannot yet be relied on to make predictions. The natural sources of stratospheric ozone layer have not yet been delineated, theoretically or experimentally. The Antarctic ozone hole is ephemeral. It comes and goes. It seems to be controlled by climatic factors outside human control rather than CFCs. And that's exactly the same argument. We don't understand it. It's natural variability. It's identical argument. And can you put it back up? In the next paragraph, the New York Times reports, talks about the disadvantages of CFC substitutes. They may be toxic, flammable, corrosive. They certainly won't work as well. They'll reduce the energy efficiency of appliances. They'll deteriorate. $135 billion of equipment use CFCs in the United States alone, and much of this equipment will have to be replaced or modified to work well. Eventually, that will involve 100 million home refrigerators, air conditioners in 90 million cars, central air conditioning plants in 100,000 large buildings. Good luck. The total costs haven't even been added up yet. And again, windmills don't work. The costs are going to be extraordinary. And you were around the 90s. Do you remember the economic apocalypse that happened when we replaced CFCs?
It didn't happen.
The economic apocalypse didn't happen. We replaced them, and none of that happened.
What did they replace them with?
With other CFCs. The original F11, F12 got replaced with these things we call HCFCs that are less damaging the ozone layer, and none of that happened. And those people are the true alarmists in the debate. The people that say we can't do it, because we can do it, and they're just trying to scare people into not taking action. So, you have a question?
No, I was going to say, I think Koonin's take on replacing things is essentially that there's so many people in third world countries, in impoverished areas, that rely on fossil fuels, and that eliminating fossil fuels will be devastating to those environments because these people are going to lose out on massive amounts of income, and economically it's going to affect them in a disastrous way. That's his take, right?
I don't want to put words in his mouth. Certainly he argues that it's difficult to transition. I think he said at one point during his interview with you that fossil fuels are the cheapest energy source, which is not true. In fact, I have a slide on that. If we go to slide 33, this actually shows that now. So your viewers may not know this, and in fact, a few years ago, fossil fuels were the cheapest energy source, but the prices are plummeting. So this is a plot from Lazard, what they call the levelized cost of energy. And you can see on the left side, it's the price in 2009. And you can see the top dot is solar. And it was extremely expensive in 2009. And then as you go down, 2019, wind and solar are now the cheapest energy sources. Gas is close. But wind and solar, they are the cheap energy sources now.
Is it possible to replace all of the fossil fuel energy that we get with solar?
Oh, wow. That's a great question. And I guess we'll just sort of let the conversation flow as it wants.
Sure.
So, yeah, let's talk about what it takes what would a grid that's carbon-free look like? Okay, so everybody who's capable of tying their shoelaces knows that wind and solar are intermittent. So solar doesn't produce energy at night. Wind doesn't produce energy when the sun's not blowing. So everybody knows that. Okay,
when the wind's not blowing.
When the wind's not blowing, yes. Everybody knows that. So if you want to create a reliable carbon-free grid, you have a grid that's about, on average, produces 75% of its power from wind and solar. And then the other 25% is what we call dispatchable firm power. So it could be nuclear, could be geothermal, could be hydro. It's a power source you can turn on and off to balance the variability of wind and solar. So when the wind stops blowing, you turn up your dispatchable, and when you're getting lots of wind and solar, you turn it off and you let wind and solar run.
I was under the impression that wind was not very effective, that these windmills don't produce that much power.
I mean, some days in Texas, it's half our power.
Half of our power comes from wind?
If it's a windy day,
really?
We get an enormous amount of power. Yeah, Texas has an enormous amount of power that we get from wind on windy days. Some days you don't get a lot of power, but
that's
you do.
Incredible. I did not know it was half of our power.
Yeah.
So conceivably, with solar and with wind, we could power the entire state.
And you need some dispatchable power.
Right.
You need some nuclear, you need some geothermal, you need something that you can balance the renewable energy with.
But much less than we're currently using.
That's right. And so you might ask reasonably, why use wind and solar at all? Why didn't you just build 100% nuclear? And that would work, and I would actually support that. But that's much more expensive. The wind and solar are very cheap at this point. And in fact, the marginal cost of wind and solar energy is zero. They produce energy, an extra joule of energy at no cost because they don't have any fuel.
Right.
So if you want to pay the least amount for energy, what you want to do is you want to have a grid that's mainly wind and solar, but then you have to have this firm power that makes up for it when wind and solar don't produce, because there are going to be times when they don't produce. We know that's going to happen.
So wind and solar also rely on there has to be some sort of battery that collects the energy, correctly?
No. So that's
solar
a different.
Does, right?
No, they really don't. So that's part of why you need to have dispatchable energy. You don't really need energy storage on a grid. Now, there are some benefits to energy storage, especially storage that lasts a few hours, because you can collect energy at noon when solar's producing lots and shift it into the evening. So you can shift the energy a few hours. So you might want to use batteries for that, but you don't really need long-term storage to run the grid. You just need some sort of dispatchable power to balance the renewable.
So is when you have batteries that are attached to solar systems, is that just for individual use, like for off-the-grid homes and things of that like?
No, it'd be industrial scale batteries. And again, the idea would be to shift power from when you're getting the most solar, which is noon, to when the demand is the highest, which is a few hours later.
Right, but what I'm saying is for individual homes, most of them have battery backup systems. They have systems that store the solar, correct? Like I used to have a system like that.
Yeah, I actually don't know the statistics. I think most people that have solar panels in their houses don't have batteries. I think some people do, but most don't have solar.
So they connect to the grid as well.
Yeah, so
if the grid goes down, that means their solar power is down as well, right?
That's right. So for most people who have solar panels in their house, they actually have an interlock system that when the grid goes down, their solar panels shut off. And the reason to do that is for safety of the power line workers. They don't want, if the power line workers think there's no power on the grid, they don't want these solar panels feeding power in. They walk up and they get shocked. So the solar panels actually are designed to shut off when the power goes out. Now you can put a battery on your house. You can have it disconnect from the grid, and you can basically make your house a little island. But most people don't do that.
If they do that, is it really possible to power your entire home through solar that way?
You can. That's a question of how much you want to invest. If you certainly could do that. I think if you have big enough batteries, you could do that. But the grid is a good, reliable backup most of the time, and so I think that's what most people rely on. They just hook up to the grid, and when they're not generating enough power, they're pulling energy off the grid, and when they're generating excess power, they're pushing it onto the grid.
Right, but I think one of the things that people like about the idea of solar power is that you're off the grid, is that you don't have to rely on anything. Like if the big freeze happens again and everything shuts off, you'll have a refrigerator, you'll have heat. Right.
Oh yeah, no, I think that's right, and I would love to have a house like that, but most people don't have houses that can disconnect from the grid.
So most of the people that do have solar power, they have solar power and they're attached to the grid. So solar is just a way of saving money and saving energy costs and saving your energy consumption.
Yeah, that's right. So it's a way to pay less money for your power because you're not buying money off the grid.
And with wind, they have these massive wind farms, right, where they have these giant propellers in the air and those generate. Right. How much energy does one of those things generate?
So order of magnitude, something like 10 megawatts is sort of a general number for it. So, and to give you an idea, a megawatt is sort of a diesel locomotive. So kind of 10 diesel locomotives. A big coal-fired power plant is order a gigawatt, 1 billion watts. So you can think of 100 windmills as about equal to a nuclear power plant. But
really?
Yeah, but
that's strong?
Well, I mean, if we're talking order of magnitude, maybe it's 200. Yeah, but these big windmills, these windmills are enormous. Have you ever seen one?
Yeah, I have. They're pretty crazy.
They're enormous. I mean, you can't. And if you haven't seen one, you just can't imagine how big they are.
Yeah, we saw one. We were taking a drive through the middle of Texas the other day, and we saw one, and it was so close to the highway, and it was facing the highway. And I had this irrational fear that the windmill was going to break off and go rolling down the road and crush us.
Yeah, obviously,
I know that
didn't
doesn't
happen.
make any sense, but that's how big it is.
Yeah, no, they're enormous. But I think the important point here is wind and nuclear are not exactly substitutable powers. Again, they play different roles in the grid. And this leads, you mentioned the Texas freeze. Let's talk about the Texas freeze, because I think that was really a great example of how the grid is supposed to operate and why it didn't operate. And so, Texas, we have a lot of wind and solar. We also have a lot of natural gas. So in Texas, natural gas is the power source that backs up the renewables. When the renewables are not producing, natural gas is supposed to step in and back it up. I mean, that's the way our grid actually works. We run as much wind and solar as we can, and anything else is made up with natural gas. There's a little coal, a little nuclear. And so during the Texas freeze, the renewables went down. They were not producing very much power. And again, people play this up like this is a problem with renewables. This is not a problem with renewables. We know renewables stop producing some of the time. And when that happens, you rely on your firm dispatchable power to make it up. And that was the failure. The gas system did not back up the renewables.
And why was that?
Oh, that's a really excellent question. So it didn't back up because the gas supply essentially was choked off. So especially in West Texas, a lot of the gas that comes out of the ground has a lot of condensates in it, things that condense and freeze. So heavier hydrocarbons, water, and at the very cold temperatures, it actually froze the wells, so the gas couldn't get out. It plugged the wells up. And then what happened is, so you get this reduction in natural gas flow, and so then the power started to go down. And this was very sudden. This was in the middle of the night on February 15th, 2021. The power started to go down. And then what happened was a lot of the natural gas infrastructure is powered by electricity. They have these compressors, they have valves. And once the electricity started to go down, all of the rest of the natural gas infrastructure started to fail. And so you lost even more natural gas. So it was really this cascading problem with the natural gas system, are the dispatchable power. And, that event cost about $200 billion between how much we had to pay for gas, plus all the damage, all the pipes that froze and burst. I mean, it was an enormously expensive event, one of the most expensive events Texas has ever experienced. for that $200 billion, which is all going to repair pipes, it's going to these really rich natural gas guys, we could essentially build enough nuclear power to replace most of our gas power if we had just done that. But instead, we're spending all that money repairing houses that were destroyed because the natural gas system failed. I mean, it's crazy to me that we still rely on these systems that we can talk about fossil fuels, but fossil fuels have many huge disadvantages, not just climate change, but many others. And we could fix this if we wanted to, but we're not. And we're just sitting here paying money year after year for these failures of fossil fuel systems.
Now, people have a fear of nuclear power based on Chernobyl and 3 Mile Island and Fukushima and the like. What is the current technology? Like when you're looking at nuclear technology in 2022, how much safer is it? How much more effective and efficient is it? And what's the best example of a new modern nuclear power plant?
Yeah, so let me just say right off the top, I'm not an expert on the details of nuclear power. Certainly, people are worried about nuclear power, meltdowns, et cetera. The way I look at it is you have to trade off costs and benefits. And you look at climate change, we can go over the litany of terrible things about fossil fuels, and I'd be happy to do that. And if you look at all of those and you say nuclear, my view is I'm willing to take some risk with nuclear power to avoid all of these other really terrible impacts. Now, I do know that there's a lot of work being done on new technologies for nuclear, these small modular reactors, things that hold the promise of better nuclear power. And maybe those will come out. But even with kind of existing technology, from what I understand, I'm willing to take the risk.
My understanding of technology, the nuclear technology rather, is that in 2022, there's many more fail-safe measures than were when they designed, say, the Fukushima system, for instance.
Yeah, every time you have a disaster, people go into it and they say, what went wrong? And then you learn lessons and you incorporate those into the new plants. You do that with plane design.
Right.
You do that with any kind of big industrial thing. So there's no question in my mind that that's right, that they're safer today than they were in the past. But let me say, while I support nuclear, and if Republicans came out and said, we will solve climate change by building nuclear, I'd be 100% gung-ho. By no means am I one of these nuclear bros that you might see on Twitter who, fusion is 10 years away. And, I would also take geothermal.
What are the nuclear bros saying?
Oh, there are people on Twitter who will say, fusion is right around the corner. And,
you call them nuclear bros?
Yeah.
Why do you call them nuclear bros?
They're usually sort of aggressive, youngish men. They probably watch this show. They're probably steaming angry right now and are on Twitter. They're actually on Twitter right now searching for me.
So there's nuclear fans? Is that what you're saying?
Yeah. Oh, okay. Yeah. You should. Here's a test. Go on your Twitter feed and say something like, I hate nuclear. Just say that and tweet it out and see what the reaction is.
I don't read Twitter.
All right. Well.
Fortunately.
Yeah. Okay.
But I just post and ghost. I get out of there.
Yeah. That's a good way to do it.
But when you're saying nuclear bros, and so is your impression that these are real people that are just enthusiastic about nuclear power, or are these trolls, or are these people that work for some sort of a lobby and they're enthusiastic about getting nuclear pushed forward because they're a part of the industry?
I think they're honestly enthusiastic about nuclear power.
But they're young guys who are bros.
Yeah, exactly.
That seems odd to me.
This is my experience on Twitter. So, your mileage may vary.
They might be fucking with you. They might have found you to be a little sensitive. Do you know that they do that? They find a little soft spot. They start poking.
That is true. But, I don't respond on Twitter a lot. I view it as kind of a push medium.
Good for you. So there's nuclear people that are maybe a little overly enthusiastic about nuclear.
Yes, that's a good way to put it.
And when you looked at Steve Koonen's assertions about the impact of fossil fuels on the environment and carbon in the environment, and what about human use is responsible for that? He put a bunch of percentages, like how much of it is agriculture, how much of it is transportation. Do you dispute his positions on those, that the amount that humans, with fossil fuels in particular, have an impact on the Earth is smaller, or at least less significant than a lot of the alarmists would say?
No, I think the numbers he gave are pretty accurate. And let me just sort of preface this by saying I think that the facts that Steve Koonin gives are largely accurate. I could dispute one or two, but the things he says are right. But you have to understand that he's really acting like a defense attorney for carbon dioxide. And a defense attorney, they don't lie. They get disbarred if they go in front of a court and lie. But what they do is they give you this carefully curated picture of reality. Just like, you sit down with a defense attorney and he explains why his client is innocent. You're going to walk away thinking, that person's getting railroaded.
Right.
Of course he didn't do it, because you're not hearing the whole thing. And so it's not that what he said was wrong. In fact, many times he said, no one's ever been able to prove anything I say is wrong, and I have footnotes for everything. And that's correct. It's what he's not saying. It's the where he emphasizes his uncertainty and lack of uncertainty. That's really what's misleading, I think, in the argument. So,
can you give me an example of that?
Oh, sure. So he spent 5 minutes, well, maybe not 5 minutes, 2 minutes talking about climate models and how hard it is to do. And, it's like climate models are very uncertain. And then at another point, he talks about the economic models. He says warming of, and again, I don't know the exact quote, but warming of 2 or 3 degrees, why, that's 4% of GDP. That's nothing. And, economic models are terrible. If you don't believe the climate models, the economic models are absolutely awful. And I can go in, I can explain that. In fact, let me tell you a story about economic models and why you should not believe them. And we'll get back to how he doesn't talk about the uncertainty in those at all. So in the 2010s, the Obama administration put out this thing called the social cost of carbon. And that's basically the cost of the damages from 1 ton of carbon added to the atmosphere. So they say if you emit 1 ton of carbon, we have our economic model, and it's going to cost $35 of damage. And they have a way of doing it. I won't go into details. Then the Trump administration comes in, and they redo the calculation, and they get $3. Now, what changed? It wasn't the science. It was the assumptions going into the economic model. The Trump administration didn't put very much value on future people and didn't put any value on people outside of the U.S. And so what that means is the difference came down to a value judgment. Do we care about damages to the rest of the world? Do we care about damages to future generations? That's not a scientific question. That's a moral question. And these economic estimates are completely suffused with value judgments. And they're really, I could go on about
Could you just expand upon what those economic damages would be and how it would affect people?
Sure. So, damages of, so let's talk about the impacts of climate change. Actually, let me get to that in a second. Let me just wrap up what I'm saying.
Sure.
So the economic estimates are absolutely unreliable, in my view. And Dr. Koonin, he didn't even mention that there was uncertainty in it. He says it's 4%, as if that's a perfect number. And that's a classic merchant of doubt strategy. This number over here, which is not good for my client, that's a terrible number. Let me tell you why. This number, this supports my client, it's perfect. And so that's a classic merchant of doubt strategy. And he does that repeatedly. It's not wrong. I can't say what he said was wrong, but I can say that it was a choice he made to bolster his client. Now, which is carbon dioxide. Now, let's talk about the impacts of climate change, is what you're asking. So let's talk about so when you warm the climate, you do a bunch of things. But
not just the impact of climate, but you're saying that he is not looking at it in terms of like how it affects the world.
Well, that was an example of the Trump administration, right. How the assumptions that go into these economic models can make a factor of 10 difference in what you estimate. And if the assumptions that an economist makes when the value judgments, the values of the economist, when they're doing the calculation, can make a factor of 10 difference, you can't look at that as a reliable number. That's my, that's my opinion. In fact, I have a slide that shows the damages. Let me find out where that one is.
So, in your opinion, he's looking at it leniently. Oh,
I just Googled that, and yesterday this is a news article from a federal court decision.
It says federal judge halts Biden administration from using social cost of carbon. Can you scroll up so I can read what it says? Federal judge is barring the Biden administration from using the social cost of carbon put into place on January 20th, 2021. The decision issued Friday affects the interim figure in place now, as well as an updated metric expected to be issued later this month. Huh.
Right. And so it says there $51 per metric ton. So that's the value. If this were the Trump administration, they would put $5 per metric ton on that. And again, which value is right. And this shows you that there's huge uncertainty in the estimates.
So it says here, the case brought up by 10 states, including Louisiana and West Virginia, challenged the interim metric, arguing that it was arbitrarily set and would increase the cost of energy production and other activities. So how much of an effect does this have on what you're saying?
This is noise. I mean, this is not. My point is about the reliability of these economic estimates, and these reliabilities. We have no idea what the cost of climate change is going to be. And
so
I think
when he's saying, when they're ruling that you can't use that term, the cost of, what exactly they're saying? Put it back up again so I can see it one more time.
Yeah, I think this is actually a lot less than what you're trying to. This is probably
scroll back up to the top so I can read the headlines again. So it's saying the federal judge halts Biden administration from using the social cost of carbon.
They're not stopping people from using that. What they're saying is the Biden administration reversed the Trump administration. And when you do that, there are certain rules about how an administration can change an executive order from a different one. And what they're saying is they didn't quite follow the right procedures. I haven't read this, but that's my interpretation.
It says here the plaintiffs did not challenge a particular use of the Biden administration's social cost figure, but rather its potential applications. So I guess what they're saying is that they don't want the Biden administration applying this idea of social cost.
Right. And if you look at it, it's Louisiana and West Virginia. Those are fossil fuel producing states. And, the social cost of carbon is bad for fossil fuels because it makes them pay for the impacts or at least it incorporates the cost of the impacts into decisions. But this doesn't challenge this doesn't have any impact on what I'm saying about these economic estimates are not reliable. And so when Dr. Coonan says it's only 4% of GDP, maybe it's 4%, maybe it's 80%. And
80%?
Sure. Could you go to slide 28? So to give you an idea of how economists have no idea what the impact does, this is a plot of the damage. So it's the reduction of GDP as a function of temperature. Now, unfortunately, this is in Celsius. To convert from Celsius change to Fahrenheit change, it's multiplied by about 2. So 5 degrees Celsius is about 9 degrees Fahrenheit. And you can see that these estimates don't agree at all. Some people say that a 5-degree warming Celsius, about 9 degrees Fahrenheit, would only reduce GDP by, 8%.
But that's a giant number, isn't it?
8% is this way.
Is anybody forecasting that kind of a rise in temperature?
No, but let me.
So why use that?
Well, I'm just saying at the end, you can look at, let's go to 3 degrees. So 3 degrees.
But is anybody even saying 3 degrees?
Yeah, 3 degrees is where we're at. And 3 degrees centigrade, about 5 degrees Fahrenheit. That's where we're going now.
How much of a time period?
That's 2100. So in 2100, we will be 5 degrees warmer.
Overall?
Global average, yes.
Wow.
So 5 degrees is high. That's at the very top end of the worst case scenario. 3 degrees Celsius, 5 degrees Fahrenheit.
I'd never heard it that high. I'd heard like a couple of degrees. Maybe I'm reading the wrong stuff.
Well, okay, so this is where being an American is a disadvantage. We talk in Fahrenheit. In Celsius, it is a couple degrees. It's 3 degrees Celsius. That's a couple degrees.
They tried to push that on us when I was in school. We should have just accepted it.
We should have accepted it.
And soccer. They were trying to push soccer as well, remember?
That is correct. So 3 degrees Celsius is about 5 degrees Fahrenheit. That's where we're going. And if you kind of look at 3 degrees, the estimates differ by a factor of 10. Some people are saying 20% loss of GDP. Others are saying 2% or 3% loss of GDP. And all of these are lower limits. It's going to be worse than this. And the reason they're lower limits is because the majority of them add in, they do this, we call a bottom-up approach. They say, okay, what's the effect of agriculture? And what's going to be the effect of sea level rise? And what's going to be the effect of warmer temperatures on productivity? And they kind of sum them up. But they leave out all of these things. Ocean acidification. How do you even value that? Permafrost melting. How is that valued? All of these things are left out of many of these estimates. And so, the important thing, again, I just can't get over is we have no idea what the cost of climate impacts are going to be. Anybody who tells you that they know what 3 degrees is going to be like is either a liar or a fool. We have no idea. Now, I then cannot tell you it's going to be bad, but I think it could be bad. It could be very bad, especially when you look at the Texas freeze. I mean, that was a really bad event. That was $200 billion of damages. And
that's a unique event, though, isn't it? And isn't it also unique in that Texas has its own grid?
Sure. Every event is unique in its own way. But
Right.
the point I'm trying to make here is how vulnerable we are to these climate impacts. We're extremely vulnerable to these changes. And so this idea that it's going to be nothing, it's going to, instead of, you won't even notice it. I mean, nobody can tell you if that's right or not. And in many ways, that's the biggest reason to act on climate change, because we don't know.
This raise in temperature and the associated cost that's involved, what would that cost be because of? Would it be flooding near the coasts? Would it be drought? Like what would be the added costs?
Oh, it's everything. I mean, we live in a world that is optimized for the temperature range that we're in. So when you build a bridge, for example, the engineer says, okay, what's the temperature range that this bridge can experience? Because bridges expand and contract, and you have to make sure that it's like, okay, this is the range. And then as you depart from that, I have some slides on that, which I will look up as I'm talking. Can you go to 46? We're just now getting to the point where we're beginning to depart from the range of infrastructure. So, for example, you can see on the left, heat wave made this bridge too swole to function. And so that's one thing. And you say, well, that one thing by itself, it's probably a bridge that opens.
What? Right. And then, yeah, it looks like it is. And then the other one, does it look like it is?
Well, I don't know the details of that bridge, to be honest. I'm sure in the comments.
It's got the lights.
Yeah.
Are those lights the ones that they use when they...
Chicago. I could check real quick.
Yeah, check that. Because
Bridge.
that seems weird.
But in any event, I've seen this many places where bridges, it gets too hot and the bridges, they have to close the bridges because
because of the asphalt and...
They expand. They're made of metal and stuff that expands when it heats up. And the slide on the right, which you can't see more, shows some train tracks. And again, when you build train tracks, you assume a temperature range. And
so it does lift.
There it is,
yeah. So it got too swole from... That's wild that they lift like that. So it got too swole and then it wouldn't disconnect. And separate.
Exactly.
And then the one on the right, that looks really old. Like, what is that from?
I don't know exactly when that picture was taken.
Extreme heat caused railroad tracks in New Jersey to buckle, giving them a spaghetti-like look.
Because they expand too much.
Or because they made it in New Jersey.
Yeah.
A bunch of mobsters. They cut corners. What do you think, Jamie?
Well,
I've never seen that before, but that is pretty wild.
It's because there's a body under there that's decomposing.
So that is crazy. Like, I did not know that if it got that hot, that it would turn and wiggle like that.
Yeah, I mean, here's the thing. They're pointed towards each other and they expand. And if they expand into each other, they buckle.
Right.
And the thing you have to understand is we have trillions of adaptations exactly like that to the climate. When the Pacific Northwest heat wave occurred, pavement in Portland was buckling because it just got too hot. They never expected it to get to 120 degrees,
right?
Or 115, however it got that high. And so when the temperature departs the range that we're kind of in now, we're just there it is. Actually, I had
why roads in the Pacific Northwest buckled under extreme heat. Oh wow, look at that. That's crazy.
Yeah,
looks like a whole volcano underneath it.
Yeah, that's right. And I mean, this is going to be incredibly expensive to fix, the trillions of tiny adaptations we have. And so this idea that, this is not going to be expensive. Nobody has any idea how expensive this is going to be. Nobody. And so again, for somebody to come on here and confidently say it's going to be 4% of GDP with this much warming, that's defense lawyer. That's what defense lawyer says. My client's a great family man. And it's going to be,
Here's another one. Heat so strong in rural Australia it bent a railroad track. Look at that. That one's nuts. That's even crazier than the one in New Jersey. That is insane. Is that real?
I don't know. I think they're fixing it. I can't tell.
Oh. Well, it's just, even if they are fixing it, how'd the metal get bent like that? Look how the asphalt's pushed, or the rocks rather, and gravel's pushed this side. So what Coonan was doing in your mind is looking at absolute best case scenario and ignoring all the potential things that could go sideways, like these infrastructure things you're pointing out.
Yeah, I mean, what does a defense lawyer do? My client is an upstanding family man. CO2 is plant food. My client, could not have done it. It was somebody else. He was talking about it's ocean cycles. He mentioned that during his interview. And what he doesn't tell you is the CO2 was found with the victim's blood all over him, and he was holding a knife, and there's videotape of him stabbing the client. And I'd be happy to go over why we're so. I mean, twice you asked him what fraction of the warming is due to humans, and he basically blew you off several times, saying, "Oh, we have no idea." And that's one of the things that's absolutely wrong.
Okay, so what fraction of the warming is due to humans?
So the best estimate is that it's 100%. It's all the warming. So let me explain why that's the case. So begin with, let's be clear, we're talking about the warming over the last century plus, last 150 years. So if you could go to slide 23, let me explain, and I'm going to give you kind of a cartoon version. This is actually how I teach my undergrad class, at what we call detection and attribution. And the first thing you have to realize is that if the climate changes, there has to be a physical reason. You have, if a house is burglarized, somebody did it. And if the climate is changing, there has to be a reason. So we can list the suspects. So this is from The Usual Suspects, of course. And we know what's changed the climate in the past. And so we can investigate them. So we know that continental drift, the fact that the continents are moving, that can change the climate. We know that the sun's output, the sun is the ultimate source of energy for our climate. If the sun gets brighter, that could cause climate change. Orbital variations, that's what actually drives the ice ages. It's the fact that the Earth's orbit varies over long time scales. Ocean cycles, that's what he said, things like El Nino. He said, well, we don't, that could be it. And then finally you have greenhouse gases. So can you go to the next slide? And so we can exclude all the suspects. We can exclude continental drift. It's too slow. The continents haven't moved in the last century. Orbital variations, also too slow. That's a 100,000-year process. The sun, we have observations. We measure the output of the sun. It's not getting brighter, at least since we've been measuring them from the 70s. Ocean cycles, that one actually is the hardest one to exclude, but we don't have any evidence to support it. So imagine, someone was on trial, and the only evidence that they did it was that they didn't have an alibi. There was actually no evidence that they did it. If you were on a jury, you wouldn't convict them. They said they were home playing their Xbox, but nobody saw them. And so they obviously murdered that person. You would not convict somebody for whom the only evidence is absence of an alibi. And that, for ocean cycles, that's the only thing you can point to. We don't have, we can't rule it out, but we don't have any evidence that it did it. And then you have greenhouse gases. So I like to call greenhouse gases the world's dumbest criminal. It dropped its wallet at the crime scene. It, fingerprints. There's videotape of it committing the crime. It was bragging to his friends that it did it. When they arrested him, all the stolen stuff was in the trunk. Can you go to the next slide? So again, I don't know if you want to read this, but we have massive amounts of evidence that carbon dioxide is responsible for the warming of the last 100 years. And there's no other explanation. And you put it all together, the scientific consensus is that we're responsible for all of the warming, 100%.
So there's a lot of people that are just listening to this, so we'll read this off. The different things you highlighted are theoretical reasons why adding CO2 will warm the climate. CO2 is going up. Geologic record shows correspondence between CO2 and temperature. Fingerprints and climate model support.
Yeah,
CO2.
I could talk a little bit more about this.
Sure.
So we've known since the 1800s that if you add a greenhouse gas, those are gases that absorb infrared radiation. If you add that to the atmosphere, it's going to warm the climate. We've known that since Arrhenius in the 1890s. We also know that carbon dioxide is going up. All right. I don't think there's any dispute about that. It's going up because humans are consuming fossil fuels. That's the main reason. And so you put those together, and in the 1890s, people were predicting that we would see global warming. That was 1890s. They said, we can't see it yet because we don't have measurements, but this is going to warm the climate. So indeed, it is, when you see the climate going up, you think, okay, that makes sense. If you look back at the Paleo record, we have reasonable estimates of what the climate was back 1 billion years. Not super good, and you have to infer them. There's obviously uncertainty in that. But you could see that in periods when the carbon dioxide was low, there was a lot more ice on the planet, because you can tell if there's ice covering regions of the planet. And so you can see this correspondence between low CO2 and lots of ice. That's not perfect, and if you want to, you can point out a period, well, it's high CO2 here, but it's a pretty good correspondence. You put that slide back up so I make sure I don't forget.
Is there any instances of high CO2 but low temperatures?
Can you go to slide 26? Actually, I can show you the data. So this plot, the bottom plot shows millions of years, and the left-hand axis, which goes with the orange line, is atmospheric CO2. You can see atmospheric CO2 varied from 2,000 parts per million, which is about 5 times as much as there is today, to 250 parts per million, which is about 60% of what it is today. And the blue shows how far down, that goes with the right-hand axis, that shows how far down the ice went. And you can see that in periods when the CO2 was low, there was a lot of ice. Now, you can also see there's some variability that doesn't necessarily reflect itself with ice. So if you go back 400 million years, right before the CO2 line starts, you can see a period that might have high CO2 and ice. But, there are lots of other things that could be going on. A single outlier like that, you don't want to use to contradict the overarching picture of the trend. Going back to that line, the next one is called fingerprint. So what a fingerprint is it's a way to separate various forcing agents. So, for example, if the sun were causing climate change, we would expect the entire atmosphere to warm. That's a prediction that you can work that out just theoretically. If greenhouse gases are causing the warming, the lower atmosphere warms, the upper atmosphere cools. So that's a fingerprint. And indeed, that's what we see. We see the lower atmosphere warming. We see the upper atmosphere cooling. That's a fingerprint of carbon dioxide.
What would it normally be? If there wasn't the amount of greenhouse gases, how do you determine? Like, is there a percentage in terms of like what's warm in the lower atmosphere versus cool in the higher atmosphere?
Right. So we're just looking at trends.
Right.
So we're not concerned with what's normal. We're just concerned with what's been happening over the last. We've been measuring upper atmosphere maybe 50 years on balloons, and over that 50 years, you can see temperatures going down. Actually, probably not 50 years, maybe 30 years. You can see temperatures going down in agreement with what you would expect from adding carbon dioxide. And there's some other things going on. There's ozone depletion, which also affects the trends in the stratosphere.
Sorry, how do we know that the temperature in the upper atmosphere goes down when you add carbon dioxide?
Okay, that's a good. I often ask that question to graduate students. So basically, you think what's a good way to think about it. So when you add carbon dioxide to the atmosphere, I'm trying to think about a way to say you increase the emissivity of the stratosphere. So basically, probably the best way to say it is when you add carbon dioxide to the atmosphere, if you add it to the lower atmosphere, you're basically trapping heat. If you add it to the upper atmosphere, you actually increase the ability to radiate to space. And so by adding to the upper atmosphere, it's radiating directly to space, and so it actually can cool the atmosphere. In the lower atmosphere, it doesn't have the ability to radiate directly to space, and it basically just traps heat. Now, I'm going to get angry emails about that because that's a great simplification of it, but that's basically the way I think of it. But the important thing is this is really firmly established theoretically.
Okay.
And I doubt Dr. Kuhn would argue with that.
So clearly there's an observable trend that matches the model that high CO2 is causing a warming of the lower atmosphere and a cooling of the upper atmosphere.
It's not, and it's important to say, this is not a model result. This is fundamental physics. This is just a few equations. This is not a global climate model. I mean, you don't need that kind of model. This is just simple physical principles applied to the problem.
Does anybody argue against this?
I don't think anybody would argue with that point, fingerprint.
So that fingerprint shows that greenhouse gases are responsible for a clear and measurable warming.
Yeah, I mean, here's the point. Let me just reiterate this. Dr. Kuhn, he doesn't say anything that's wrong. He just doesn't talk about it. Mm-hmm. So he's never going to talk about the CO2 fingerprint because that doesn't support his client.
Do you think he's doing this because of his, do you have an opinion about this? Is he doing this because of his past working for BP working for previous administrations. He worked for the Obama administration, which was a more environmentally friendly administration than the Trump administration. But like, what do you think would be the reason or the motivation behind doing something like that?
I don't care to speculate. I actually have no idea what causes people to say these things. But as I said before, he's not unique.
Right.
He's not the first person in climate change to say this. What is kind of interesting is over time, the Coonan-like person has changed their views quite a bit. In the 1990s, the people like him were saying the Earth's not warming. And then they were saying humans aren't having an effect. And then as those arguments became increasingly ridiculous, now he actually has in many respects, I think we actually agree on a lot of things. He agrees the Earth is warming. He agrees humans are having influence. He's always playing up uncertainty to get to a conclusion that his client he's trying to create reasonable doubt. He's doing what a defense lawyer does. Reasonable doubt is his product. In fact, there's a memo from a tobacco executive which explicitly says that's our goal. We're not trying to win the debate. We're not trying to convince people that smoking is safe. We're trying to create doubt in the mind of the general public. And that's exactly the goal here. It's not to prove that, because he can't prove that
Right.
carbon dioxide is not. He's just trying to create doubt. He's trying to slow down action. At least that's going to be the net effect if he's successful. And again, I don't understand. I'm not going to say why he's doing it. I don't know.
Now, when he talks about it and he shows these charts of, a period of many hundreds of years and the temperature of the Earth over that time, it does seem to be having this fluctuating effect which mirrors what we're seeing now.
Not really. Well, it depends exactly what you're talking about. So if you look at the last 1,000 years, there's no period like the last 100 years.
In what way?
I wish I had a slide of it. I don't. But the last 1,000 years, the temperature was basically pretty flat, and we've had a 1 degree rise in temperature in the last, it does look like a hockey stick. You've probably heard of the hockey stick. Mm-hmm. It does kind of look like a hockey stick. And, so the Paleo record doesn't really support, the historical record doesn't show anything like last century. Now, let me be clear. The argument in favor of carbon dioxide is not that you can't go into the historical record and ever find anything like that. That's not the argument. The argument, as I laid it out, is we know carbon dioxide traps heat. We know that. That's fundamental physics. We know we're adding carbon dioxide to the atmosphere. That's fundamental physics. We know the Earth is warming, and it's warming about as much as our theories suggest. So a lot of what this is it's just kind of a shiny object to distract you. Like, let's talk about Greenland melting in 1930. That's a distraction. It doesn't take away from the fact that humans are warming the climate, and that as the climate warms, Greenland's going to melt a lot more.
So there are these aberrations, and you look at long periods of time where it does get unusually warm or it does get unusually cool. But what you're saying is, make no mistake about it, what's happening right now is unusual, and it's caused by humans.
I wouldn't say it's unusual. If you go back 60 million years, there was no ice anywhere on the planet. There were palm trees in Wyoming. There were alligators in the Arctic. It was a different world. And it was also a high CO2 world, by the way, and that's not a coincidence. So I wouldn't say it's unusual. What I say is humans are driving this warming. And, modern human society with millions of cities of millions of people and trillions of dollars of architecture, of infrastructure, that's maybe 100, 150 years old. We've never experienced the kinds of warming that's coming. And it could be a terrible, terrible ride. Nobody really knows. And, and let me be clear, I'm speaking now as a parent, as a citizen, not as a scientist, because science doesn't tell you this. My opinion as someone who knows a lot about this is I don't want to run the experiment. I don't want to see if Dr. Coonan is right and the impacts are small. I think we should take action. And the key thing is we can take action at very low cost because, and we haven't talked about it, fossil fuels are incredibly expensive. Not the price you pay at the well, but the cost to society is extremely high. So, we can take action at low cost. It's a risk. We should do this. I'm speaking, again, that's my personal opinion, not as a scientist, because science doesn't tell you that. That's my personal opinion as a citizen.
What I'm saying about it being unusual, not that it's not unusual in terms of like historically over the time that the Earth has existed, but I mean that there's this moment where it's very clear that human beings are doing it.
Yeah, if you mean unusual that way, I would agree with that.
And that this is very measurable.
Absolutely. There's no debate in the scientific community about this.
So what can be done in terms of having an impact on the fossil fuel consumption, and what would that do to this overall model of global warming or climate change, I should say?
Yeah, well, okay, so we know basically how to decarbonize our economy. I mean, we can do it. And in fact, if I have a good slide, which I think really, probably up front, which really shows this. I will keep talking while I look for this. So yeah, we know how to decarbonize. Oh, can you go to slide 37? So, fossil fuels have already lost. So they're already on their way out. This plot is the ERCOT. So ERCOT is the Texas grid. And this shows the power that's getting connected to the Texas grid by source. And the horizontal line shows the different sources, and the bars are different years. Don't worry about the different years. You can see nobody's hooking fossil fuels up to the Texas grid. There's a little bit of gas, but it's mainly wind and solar. And there's actually a little bit of battery. It used to be, if you looked at older years, they had coal as a separate category, but nobody's hooked coal up to the grid in so long that they just lumped it in with other, which is zero.
I can't believe how big solar's impact
Yeah,
is.
no, I mean, this...
I would have never guessed that.
Yeah, no, so fossil fuels have already lost, and the reason they've already lost is they're expensive. People don't want, if you're building energy, if you're an energy producer, you're going to build the cheapest energy source, right? Mm-hmm. So it's wind and solar, and that they're winning in the marketplace. And if you go to the previous slide, so, at this point, it says renewables will account for 95% of the growth in global power generation capacity.
It says renewable energy has another record year of growth, says IEA, and then another record year for renewable energy despite COVID-19, blah, blah, blah. 290 gigawatts of new renewable energy generation capacity, mostly in the form of wind turbines and solar panels, has been installed around the world this year, beating the previous record last year. On current trends, renewable energy generating capacity will exceed that of fossil fuels and nuclear energy combined by 2026. I would have never guessed that.
Yeah, I mean, this is new. So I'm not, I mean, this
Where are these solar panels located that are gathering up this much power?
I mean, they're everywhere. It's rooftops, it's large solar plants. Are you talking about in Texas or in the world?
I mean, anywhere.
It's everywhere. In California, they're about to put solar panels over a canal. There's lots of space to put solar panels. So, for example, I would love it if they put solar panels on the parking lot outside my building, because when you walk out in July and get in your car, and it's 300 degrees in there. Not literally, but it feels that way.
Yeah.
And so I would love to have, there are lots of places to put solar panels that don't affect use at all: rooftops, parking lots, canals, and so there's lots of space to put this. And it's already as cheap. I mean, you can make an argument that maybe it's not cheaper than the cheapest fossil fuel, but it's very close. And if you look at the trend is so steeply down, that in a few years, renewables are going to wipe out fossil fuels.
Now, what about when it comes to automobiles?
Well, I mean, electric cars are much better than internal combustion cars. Have you ever driven one? I don't know what you... Okay,
I have a Tesla.
Yeah, so I mean, it's much better than an internal combustion.
The way it's been explained to me is that there's not enough minerals to support the production of enough vehicles that are made simply with electricity.
Yeah, the people make... I always find it ironic that the people who make those arguments are often people who will then tell you, the free market works, and we should get the government out, let the market. So what does the free market do if cobalt becomes rare? So people are smart, and the free market will innovate. They'll figure out ways to substitute other minerals for that. They'll figure out, the market will innovate its way out of this. If you believe in the free market, you believe the market will find some solution. So I don't know the exact...
I think they've scaled it, though. This is what's confusing, because I think I've read something that said that there are not enough rare earth minerals to power electric cars for every person on Earth, that it's physically impossible, that they don't exist in terms of the ore, the whatever the mines that we currently have that are pulling these things out of the ground.
Well, I mean, look, I would be very skeptical of that. Remember when they said we were running out of oil? This is
that's a different thing, isn't it? I mean, we've been extracting oil for a long time. We've only been making electric cars for
my point's about innovation. So innovation.
Sure.
So if it turns out there's some mineral, make it or some element cobalt or something like that. The engineers are smart. They'll figure out a way around that. I mean, I can't, leave it this way, I can't really speak authoritatively. This is not my area, so I can't give you an authoritative answer. But I generally believe in the free market. And in this case, I think the free market will work to solve that problem. But I mean, I'm not an expert in that. So let me just say that. Right.
But that's a key problem here, right?
Well, certainly, if you want to scale up all of these renewable energy sources, you have to be able to build it. And I do think that one of the concerns is not so much in the availability of these rare earth elements, but more in where they're located and how they're mined. So a lot of them are in Africa, and I do think you don't want to create problems where the mining is.
Right.
And so I do think that's an issue.
Rare earth magnets, mostly made of, say that word, neodymium.
Neodymium.
Dymium, are widely seen as the most efficient way to power electric vehicles. China controls 90% of their supply. Oh, great. Prices of neodymium oxide more than doubled during a 9-month rally last year and are still up 90%. The U.S. Department of Commerce said in June it's considering an investigation into the national security impacts of neodymium magnet imports.
Yeah, I mean, let's say you're a battery manufacturer in the U.S. You realize that if you can figure out how to make a battery without that compound, you're going to be rich. And so so once electric cars pick up, the innovation is going to be extremely impressive. And the reason I say that is not because, pie in the sky, because that's our history. That the history of environmental regulations causing advances in technology. You see that all the time. Just that plot of the price of solar and wind, that's driven by concern for climate change. Yeah, it wasn't just like it happened to happen then. It happened because people see renewable energy as a future. And so there was a lot of work done to produce that energy more cheaply. And I think that's what's going to happen with electric cars.
I know that there are some theories and there's some concepts that they're working on in terms of like making these batteries more efficient and making these batteries quicker to charge and last longer. But I didn't know that there's new technology in terms of like different minerals that are more common that could be used as batteries or in batteries.
Yeah, I mean, there's a huge amount of research. I mean, I'm not a battery person, so I really can't speak on what the cutting edge of batteries is.
But if it was innovative, would change everything.
Right, and I mean, the thing I realize is that's extremely valuable. If you're a company that makes batteries and you can come up with a different compound, something like that, that's gold.
Right.
And so they're going to do that, and that's the way innovation, the free market works.
So that's a hope, but this is something that's a necessity, right? Like if we are going to use electric automobiles for every person on the planet, this is a necessity. And right now there's just a hope that the free market steps in and finds some sort of a viable solution.
Well, as of right now, there's enough of these minerals. I mean, you can go.
There is?
Sure. Well, as of right now, you can go buy a Tesla. I mean, the question is,
but they're very expensive. Like if somebody wanted to go and buy an electric car and they were on a very tight budget, there's a lot more financially viable options that are for industrial, for internal combustion vehicles. Yeah, no, that's right. And I do think that you'll see the price of those come down because that's the way the market works. Well, actually, what is a Model 3? A Tesla Model 3 is it's not too bad. It's like, I think like 40. I think like 40K. I think they start somewhere around then, and that's an amazing car for that amount of money. 40? 45. So a little bit more. So it's not the cheapest car. No, but you're right. Most of the electric cars they're aimed at a market for people who are concerned about climate change, people who would otherwise be buying a BMW. Yeah. So I don't think there's been sort of the effort by the manufacturers to make a middle sort of a lower price point car. But I will say, the most exciting things for me is Ford and their F-150 truck. Yes. I mean, you live in Texas. You know that you pull up to the light, every other car is a F-150, it seems. And did you see the new commercial they had during the Super Bowl of the Chevy Silverado that's electric? I did not see that, but I heard about all the electric car commercials. They pissed a lot of people off because they used the Sopranos theme song, and then the kids from the Sopranos were in the ad. But the new Chevy Silverado electric looks amazing. It looks cool. It looks like, see if we can find like a photo of it. It looks like a Silverado, but it looks like futuristic. There it is. Like, look at that thing. That's electric. I mean, that thing's sick. It looks like a Silverado, but just a little bit more streamlined, a little bit more futuristic.
Oh, yeah. And if you get in and drive one, it's like, get rid of my internal combustion engine car. I mean, they drive better. They're cheaper to operate. You have lower maintenance issues.
Well, like I said, I have a Tesla, and I have the stupid one. I have the Plaid. It's ridiculous. It's the most ridiculous car I've ever driven. That's the one car I would never get rid of.
So have you ever actually gone somewhere and like accelerated, done the quarter mile as fast as it can?
What do you think? Of course I have. How dare you ask me that question? Yeah, it's preposterous. It's 0 to 60 in 1.9 seconds.
Yeah.
I had my kids in it the other day. I'm like, are you ready? Like, let's go. And it's like, when you accelerate on the highway, it's literally like you're on a roller coaster.
Yeah.
You can't believe it's that fast.
Yeah.
And it's silent.
Yeah, yeah.
So like when you pass people, you don't even feel like a douchebag. Like if someone's, if you need to merge in traffic, it's not making a loud noise. You're just going, wee.
Right.
It's a much less aggressive way of like merging with traffic.
So do you drive with full self-drive on?
No, I don't trust that.
Yeah.
That seems a little sketch.
I
mean, I'm sure it's great, but I've done it a couple times just to show people, like, watch this, doop, doop, and then like, look, it's driving. But no. I keep my fucking hands on the wheel.
Yeah,
I don't.
That's smart.
It just doesn't. I mean, I get it. It works, but it's like you don't want to be a statistic.
Right. And it works 99.9% of the time.
Not enough.
But it's that 0.1.
Yeah, it's like I want to. If I see someone acting weird up there, I want to slow down. If I see some guy who looks like he's drunk, I want to move over. I don't want to just zone out.
Right.
But I used to use it when I come home from the Comedy Store when I lived in L.A. And I used to use it for that reason because I was tired. Because, I'd come home, it's like 12:30 at night. I'd just get on the highway, go doop doop, and just for 10 minutes, just relax.
Yeah.
Put my hand on the wheel, but I'm just driving straight, and there's not that many people on the road, and it's a little bit more
I think
relaxing.
on the highway is where I would probably trust it the most.
But even then, when you see someone acting weird, like you want to, sometimes you want to drive defensively. You want to make maneuvers and.
Yeah, the human brain is really amazing at its ability to assess situations. You just wonder, the AI is not there yet. Maybe it'll get there at some point. But.
Yeah, I don't think the AI is going to spot drunks that good. Because, I'm good at spotting a guy who's either on a phone or drunk. Or then, they're kind of like drifting a little bit. I'm like, this fucking guy. And I'll either slow down or I'll get ahead of him. I generally like to slow down.
Right.
I like to keep my eye on those fucks. So, electric cars are awesome. I'm a big fan. And if they do innovate and figure out some sort of a way to, I should ask Elon about that actually, like what they're going to do, what the plan is in terms of like mass distribution.
Yeah, no, I think, I'm sure he's thinking about it. And,
he has to be.
And,
He's
again,
got an idea.
The person who cracks it will be rich.
Well, one of the possibilities, and it sounds really ridiculous, but one of the possibilities is asteroid mining. Right? I mean, because they've found these asteroids.
Possibility.
Yeah.
I mean, I think that a lot of the stuff that people talk about doing in space is going to turn out to be a lot more. That may turn out to not be economically viable.
Too difficult.
Yeah, just too. Yeah. I mean, you have to go somewhere, get the asteroid, bring it back, mine it. It's a hard problem.
Yeah. Okay. So that's automobiles. The elimination of coal-powered plants and these other things that are putting CO2 and particulates into the environment, like what can be done about those things, and how long do you think it would take to implement them, and what kind of a impact would that have on the overall effect that human beings are having on the climate?
Right. So let me begin by saying nobody talks about shutting all this stuff off tomorrow. It's like, we're going to shut this off tomorrow. There's debates about how fast to decarbonize. My personal view is that this is sort of a multi-decadal problem that you probably I think it's not unreasonable to shut down all the coal now, but the other stuff you probably want to let run out until it wears out. And then you just don't replace it with fossil fuel infrastructure. And, that's certainly achievable.
What are the offenders in order? Like what's the...
So coal is the worst greenhouse or the worst fossil fuel. Someone I know calls coal the enemy of the human race.
Do you remember when Trump called it clean coal?
Yeah. So there's some people on Madison Avenue that's like, how do we rebrand this? Clean coal. It's alliterative.
But it's like the least clean thing you think of. You think of like grabbing coal, you getting it everywhere.
Right.
You think of it being in the air.
Yeah. So coal actually kills millions of people from air pollution around the world. Every year, tens of thousands of Americans. In addition, it releases the most amount of greenhouse gases per joule, per unit of energy you generate. So it's really, so that's the worst. That's the worst fossil fuel, and we want to get rid of that as soon as we possibly can.
And the Americans that are dying from it, they're dying from actual coal, from poisoning in the air?
No, it's so coal puts out these chemicals, these small particulates. They often are referred to as PM 2.5, it's particulate matter with a size less than 2.5 microns. And if you breathe those in, those actually go deep into your lungs and get into your bloodstream. And there's lots of studies which show that coal, that if you live in very polluted air and you're breathing it in, you'll have heart attacks more frequently, strokes, all these health impacts associated with that. And it's tens of thousands of Americans every year from coal. And this is something, again, the anti-climate people, they don't talk about it. It's not something that supports their case, so they just leave that out.
Where is this happening the most in this country? What's the most polluted by coal?
That's a good question. I don't know exactly where it is, but it's anywhere that's downwind of a coal-fired power plant. And
let's find that out. Places in America most polluted by coal. I'd never heard that. I didn't know that many people are dying from coal poisoning every year.
Yeah, I mean, I wouldn't call it coal poisoning. I would call it air pollution because it's really
directly a result of coal.
Exactly. Yes.
So it's coal poisoning.
Yeah.
Coal poisoning sounds better.
Yeah, I mean, it's
air pollution sounds like it's inevitable.
I'll tell you, that's a good branding. Coal poisoning. Yeah,
coal
it is.
Poisoning.
It is. That's exactly right.
How about make T-shirts that say "fuck coal" and just put like an asterisk over the U?
I would wear that. If you, yeah.
What do we got, Jamie? Anything?
I don't think that list is super prevalent, so I'm trying to find it because it's just bringing up a lot of these coal plants are contaminators.
Right. Is there an area in North America most polluted by coal?
I was also going to say, the way I Googled it, it's probably going to give me a small city. I Googled U.S. city most coal pollution, but that's not, they're not in giant cities.
But even that small cities, it might be enough to, kill thousands of people. What do we have for, is it giving you a list?
A place in Indiana.
What's that called?
This story was written in Evansville, but I think it's just outside of that.
Evansville. I know somebody from Evansville.
I was like, can you go to slide 50? This will blow your mind.
It says there's 7 coal plants within 30 miles of this spot.
Oh, Jesus.
Yeah, you do not want to live there.
Holy shit. See what that sky looks like. Google Evansville. Who the fuck do I know? I know someone from Evansville.
I don't know what part of the city it's gonna be.
That is nasty. Go back to that again. Go back to the beginning again. Give me some volume on this. Let me hear what they're saying.
Southwest Indiana has some of the worst air in the country. People are suffering there.
I think the air quality stinks. You can feel your chest on a daily basis, how difficult it is to breathe.
There was a fine dusting of ash. It was all over the kids' play set.
These streets would be just black with coal. All the way up through the courthouse square would be covered with coal dust.
It's the sacrifice zone. Those folks have been blistered with particulate matter, NOx and SOx and acid rain for decades.
There's an inherent conflict between fossil fuel industries and public health and the environment.
Our future generations rely on our protests here today.
I'll be darned if we're going to let anybody tear down our lives in eastern Kentucky.
I think these conflicts aren't going away anytime soon.
What is this documentary?
That was it.
It's
Super
It's
Polluter.
called. Is it called America's Super Polluters? That's horrible. When you just look at the sky from there. So these poor people that live in this area. You scroll up so I could read that, please. No, I'm sorry, down. Evansville, Indiana. To see one of the country's largest coal-fired power plants head northwest from this Ohio River City on east, because there's another in the region. In fact, nearly every direction you go will take you to a coal plant, 7 within 30 miles. Collectively, they pump out millions of pounds of toxic air pollution. They throw off greenhouse gases on par with Hong Kong or Sweden. Industrial air pollution, bad for people's health, bad for the planet, is strikingly concentrated in America among a small number of facilities like those in the southwest Indiana, according to a 9-month Center for Public Integrity investigation. Wow, this is horrible. Look at what this says here. It merged 2 federal data sets to create an unprecedented picture of air emissions. They found that a third of the toxic air releases in 2014 from power plants, factories, and other facilities came from just 100 complexes out of more than 20,000 reporting to the U.S. Environmental Protection Agency. So how does the EPA allow those plants to stay open? I mean, if you're looking at what these people are saying, where they've got a fine dust of mist over their child's play sets and the streets would be black with coal, like how is that possible? How are they allowing that?
I mean, have you seen our political system?
I have.
Yeah. I mean, we have a lot of our politicians are essentially wholly owned subsidiaries of ExxonMobil, and they do what's in the best interest of fossil fuel. Let me show you I have a good slide that shows that. Can you go to 48? And just in Texas, there are 2 bills. One bill, this is the state of freedom where people should be allowed to do what they want to do. Well, some communities had the audacity to say, we don't want any drilling in our city limits. And of course, the Texas state government stepped in and said, oh, no, you cannot rule your own life. We rule your life for you. And this is
a fracking bill.
That's right. But I mean, it was really a drilling bill. So they said you cannot drill in the city limits. They passed a law and they said you can't drill in the city limits. And the Texas legislature came in and said, no, you have to have drilling. If people, we're not going to let you ban drilling.
Okay, so it says, saying that Texas needs to avoid a patchwork of local regulations that threaten oil and gas production. Governor Greg Abbott on Monday signed legislation that would preempt local efforts to regulate a wide variety of drilling-related activities. So this is different, though, than the coal-powered plant. Drilling is fracking and drilling for oil, and also natural gas, right?
It is different from coal, but the idea of what's happened is these fossil fuel producers, as they become unpopular and uneconomic, they're looking to legislatures to rescue them. So the same people who, and these are often Republican legislatures who talk about freedom, but they're happy to take away consumers' freedom if it supports the people who give them a lot of money. And effectively, that's what happens. These fossil fuel companies are so powerful now politically that they can get legislatures to pass laws to force consumers to use them, or at least to force them to continue to allow them to be extracted. And if you go to the other side, there's another Texas law where they said Texas passes law banning investments with fossil divesting businesses. So the state of Texas won't work with you if you divest from fossil fuels. And again...
What? So they passed a law banning investments with fossil divesting businesses.
Well,
so does that mean
the state won't work with a company?
So the state won't work with a nuclear company, a company that's making solar?
Imagine you have a bank, and the bank says we're going to divest all of our investments from fossil fuels, and they make a statement that.
Yes.
Then state of Texas would not work with them in some capacity.
Oh,
It's not like you have to use fossil fuels, but if you make a statement that you're divesting from fossil fuels, you're off the list from Texas. And again, in a state that, is based on freedom and companies making decisions for their shareholders, these companies that divest, they're making business decisions.
Right.
They're saying
Texas won't invest in these companies that divest.
Right, won't work with them.
Won't work with them.
Yeah, and so, And
the idea is that this is probably good for the economy. That's how they're looking at it in some way, or is it just that they've been manipulated by special interest groups?
Well, I have my theory about that.
I'd love to hear your theory.
Yeah, my theory is that these people care about getting reelected, and I think that one of the things that helps them get reelected is getting a lot of money from fossil fuel companies. So I do think that drives it. I also do think that being pro-fossil fuel in a primary in Texas is probably an advantage. But that doesn't take away the fact that, people's, the state is moving to curtail freedoms to enforce fossil fuel use, basically. And this is a state where, we believe in freedom.
Right. No, this is not Indiana, right? Evansville, Indiana, the place that's the worst with the 7 power plants in a 30-mile range. How does that happen? Like, how does anybody allow that to take place?
Well,
and is there any effort to try to stop that from taking place?
Yeah, I mean, certainly you saw that march. I mean, people are mad about it. There are lots of people who, so Obama, he had something called the Clean Power Plan. And the Clean Power Plan would have essentially eliminated coal-fired power if it was written in such a way to explicitly cause coal-fired power to basically not, there would be no more building of coal-fired power plants, and it would really have caused them to be phased out pretty rapidly. And that got hammered in Congress. It didn't, or actually, it wasn't a bill. It got hammered in the court system. It got sued. All of these states sued. It went through the court system, and it got overturned. And it essentially got abandoned.
And the states are presumably suing because there's some sort of a financial interest by the people that are putting these politicians in place.
Yeah, that's basically right. I mean, I don't have a slide of it. You might be able to find it by Googling. There was an article, I think it was North Dakota, was canceling a lot of wind leases in order to prop up their coal. So people who had leased space to build windmills, wind turbines, I don't like to call them windmills, they were going through and they were canceling these leases in order to save the coal industry.
Is there any sort of technology that can extract the particulate matter that these coal plants eject into the atmosphere?
That's a good question. I don't know. Oh, yeah, that's it. That's the article. Very good.
How coal holds on in America. In North Dakota coal country, officials rally to save a coal-fired power plant at renewable energy's expense. Look at that. Is that real? Like, look at the disgusting smoke that's pumping. Imagine living there and seeing that pumping into the air where you're raising your children.
Yeah, no, I would not want to live downwind of that thing. I would say, though, most of the smoke is probably water vapor.
So, but there is some particulate matter in there.
It's definitely putting a lot of crap into the atmosphere. And a lot of carbon dioxide.
It's just stunning that knowing what they know about Evansville, that hasn't been, they haven't put the kibosh on that.
Well, it goes to show you, I think in our current environmental or our current political system, a lot of people don't have a lot of power. It's districts are gerrymandered. There's no limits on campaign giving. And essentially what it's done is it's taken away power, especially from, a lot of these coal plants are polluting the poorest neighborhoods. If you go to Houston, you look around like the Ship Channel, the most polluted places are the poorest places. Those people have no political power at all. And they could go talk to their representative and he doesn't give
sort
a
of
crap.
like the water in Flint, Michigan.
Yeah, exactly. It's exactly the same. Those people have no power and they can't lobby, they can't and maybe their representative is pushing it, but there's not this groundswell of support in the rest of the legislature to do something about it.
So when we're thinking about fossil fuel, we can't just think about the effect that CO2 has in the environment in terms of warming. We have to think about the effect of the particulate matter and the pollution and what it's doing to people's health.
Yeah, no, that's absolutely right. So go to slide 50. This is actually, I think this will blow your mind. This is a study that came out that in 2018, fossil fuel air pollution was responsible for 1 in 5 deaths.
Worldwide,
not in the U.S.
That's crazy.
And a lot of those were in places like India that have really, really terrible air.
Is that the place that has the worst?
Probably at this point, I would say it probably is. Delhi. They have a lot of 2-stroke motors and things like that really put out a lot of crap.
Can you scroll down, Jamie, so we can see what this says?
No, that's
it. A screenshot.
Oh, I'm
you
sorry.
could Google that, but go to the next slide.
Okay.
Go to the next slide, because I think this is the other point. So, in addition to pollution deaths, let's go through the litany of terrible things about fossil fuels. So there's climate change, there's pollution, it's killing millions of people. It also is bad for the economy because of the price swings. Now, we have electric cars, so we don't really care, but if you own a gas car, the price is going up to $4, goes down to $2. That's economically destabilizing. And in fact, we know that a lot of recessions have been caused or they've been started by price swings from fossil fuels. So it's really this economic, if you have no idea what you're going to be paying, it's hard if you're a business owner or a citizen to make a decision. It's like gas is $2 a gallon. Should I spend money on tuition, or do I have to put money in the bank because I know gas is going to go up? I mean, you don't know what the price is, so it's hard to do it. Can you go to the next slide? Oh, no, don't go to the next slide. So in addition, fossil fuels are a national security issue. So, we invaded Iraq. Why do we do that? We did it twice. So we did it because of the need to maintain stability in the oil markets, especially the 1993, 91 invasion of Kuwait and Iraq. And the thing I realize is even though we don't import a lot of oil from those places, the price of oil is set by the international market. So if you buy a barrel of oil from West Texas, the price of that is set by the entire world. And so that gives people like Vladimir Putin, gives people like Saudi Arabia the ability to manipulate the price of oil and hammer our economy. So for example, 2 years ago in 2020, Saudi Arabia and Russia got into a price war, drove down the price of oil. The price of oil, the oil futures actually went negative here for a few days. And that actually obliterated the Texas oil industry. I mean, there were layoffs, there were bankruptcies. It was really hard economically. And so from a national security standpoint, we don't want those countries to be able to hammer our economy by manipulating the price of oil, which they can do. And if you look right now, Putin is sitting on this big gas supply that goes to Europe. And, there are all these implied threats about gas supply being sent to Europe. And Europe is, they need the gas. And so he's got his hand around their necks. And, that's not a good situation to be in.
So this is not a thing that we can look at in terms of a compartmentalized problem. Like
Absolutely
there's just
not.
one problem. There's all of these things chained together and they cause a cascade of issues.
That's right. And you combine that with the fact that we can switch. It's not like this is terrible and we don't have any alternative. I mean, if we didn't have any alternative, I would fully support fossil fuels because we need power. But we have an alternative that's not that expensive. People have done the studies. We know solar and wind are reasonably cheap. You build some dispatchable power, even though they may be expensive, build some nuclear plants. We could largely get off fossil fuels. There's some edge cases that it's hard. Trucks, international airline flights. We don't know exactly how we'll decarbonize those, but there's a lot. We could decarbonize the electric grid. We know how to do that.
Well, just that Indiana area alone with the 7 power plants within a 30-mile range, I mean, that seems insane. It seems like there should have been a solution offered up decades ago for that.
Yeah, there should have been. But, there's a lot of, look at, it goes back to like our government. Look at the Senate. So in order to get anything passed at the Senate, you've got to get all the senators voting. Forget even 60 votes for the filibuster. For reconciliation, they're trying to get the Build Back Better plan, which would have had a lot of climate stuff in. They couldn't get Joe Manchin, senator from West Virginia. They couldn't get him to vote for it. So, I mean, that's the problem. The problem is dysfunction in our government. It's not a science problem. It's not a technology problem. It's a governmental problem. And I think the U.S. over time is just, our political system is not responding to the needs of the people. It's responding to the needs of people who are very rich.
So this Build Back Better plan would have had something in there about eliminating these kind of power plants?
Yeah, so the Build Back Better plan had a lot of climate policy, and I don't think it had anything that specifically said these must be eliminated, but there was a lot of spending in there that would have led to a lot of good climate policy.
Isn't the problem with these bills, though, that they slip in a bunch of other stuff that people don't want to have attached to something that may be good? Like if you looked at the Build Back Better, there was a politician, I forget who it was, that held up the bill, and it was like thousands of pages. And he's like, do you think any of these people that are trying to pass this have read through this? And they probably haven't. The problem is the shenanigans that go along with politics, right?
Yeah, that's a political problem.
Yeah.
And people vote. I'm sure that guy, whoever it was, voted for bills exactly like that, but ones he thought would help his career and help his constituents.
Right.
That's an excuse of the day.
Perhaps.
Yeah.
We're guessing.
Yeah,
He
who
might
knows?
be very principled.
He very well could be. That's right.
You laugh when you say that, though. That's the
You're
world we're
laughing
living in.
too.
I know. I'm with you because that's how goofy the world we're living in when it comes
It is.
to
I mean,
politics.
It's really hard. It's really hard when you see how these people behave to think that they actually have our best interest in mind.
And to think that this is all we have. Like all we're offered is like crap and crap and crap.
Yeah.
You know, it's like the idea of the free market in terms of politics has never really manifested. Like there's never been like some better solution to the way we handle things now. It's still large corporations that are influencing politicians to do things that aren't in the best interests of their constituents, and that's how they get elected. And when they get elected, they bullshit us, and they get into office, they still do the same thing over and over and over again. It's like a magic trick that we keep falling for. It's like Lucy pulling that ball away from Charlie Brown every time he goes to kick it. I mean, every time it's the same thing.
Yeah, but I wouldn't blame us as much. I mean, there's a lot of things that the politicians do to sort of entrench their power. You know, gerrymandering is a classic thing. You know, if they gerrymander correctly, your vote doesn't count. I mean, they've literally taken your vote away from you. And, you know, you wonder once you get into a situation like that, how do you get out of it? Because you can't vote the people out because, you know, they've literally said it, so you can't do that.
And the complex system that they put in place with, I mean, it's so entrenched, and these people are so, their roots go so deep. It's so hard. You see like these Nancy Pelosi characters, these career politicians. It's like, how would you ever get rid of these people? They're so embedded into the system. And then you find out how much money they've made while being a politician and making a fraction of that a year. You're like, how are you so rich?
Yeah.
Like, what are you doing?
Yeah, and over time, it just gets worse. I mean, my 93-year-old father lives in College Station, and, you know, he was denied a mail-in ballot. I mean, he's 93, and it turns out he made a slight... They denied him because he didn't quite fill out the paperwork exactly right. And, I mean, my wife had to finally call and fix it. But, I mean, you know, they're making democracy harder, and this is all to entrench their power.
So what can be done right now that we're not doing?
Well, I mean, we just need to make a decision that we're going to phase out fossil fuels. I mean, this is, as I said before, this is a political problem. It's not a technical problem. It's not a scientific problem. It's we need to make a decision. We need a policy. And, you know, if you talk to economists, they will tell you we need to price, you need to put a price on emissions. So right now it's free to dump pollution into the atmosphere. You don't pay for it. Even though you're causing harms to all these people, you don't pay for it. And you need to price that. If you do that and you make people pay the full cost of their actions, that would go a long way towards fixing the problem.
Well, I would imagine like in Evansville, it'd be non-profitable. I mean, it seems like the amount of money that those, I mean, there should be some sort of a crazy class action lawsuit.
Yeah, no, I learned about it today, watching it same as you did. Yeah, that does seem like a terrible injustice.
So when you read a book like this that is essentially a non-alarmist perspective, you think that what this does is not just delays the inevitable, which is we do need to take a chance, but also puts us in a worse position because people are looking at it like it's not that big a deal, and by the time they wake up to it, the amount of issues that we have will have multiplied.
Yeah, I mean, I think a lot of things are going on. So let me give you an example. So if you look at where, for example, solar panels, China dominates the market in solar panels. And in 2007, I testified before the Texas House of Representatives. And I said, you know, Texas has an opportunity. We could dominate solar panels. We could start moving now. And we could, and if we don't,
you mean construction?
Manufacturing. We could become the Saudi Arabia of solar energy by building these solar panels. And I said, if we don't, we're going to be buying from China or France. Now, we're not buying them from France, but we are buying them from China.
Why'd you say France?
Because people hated France back then. Remember the freedom fries? I thought France is
a good thing. Yeah. That's what I thought you were going with.
Yeah, no, it was I was purely pandering.
Freedom fries are so stupid.
I was pandering to the people on the committee to get them to agree with me. And so, you know, by delaying, there's an economic cost to that, because when we do switch, which we are going to do it, because again, solar and wind are the cheapest energy. We're going to be buying it from, you know, wind turbine manufacturers in Europe and from China, solar panels from China. So we're giving away the economics. It's kind of like, what if we had not not let Silicon Valley grow up in the U.S. That it's sort of that level of economic activity that we're giving away by not acting. In addition, you're right. Emitting carbon dioxide to the atmosphere is effectively irreversible on any time scale that we care about. What that means is once the carbon dioxide in our atmosphere, right now, it's at about 415 parts per million, which means out of every million molecules of air, 415 are carbon dioxide. Once it goes up to some level, 420, it takes a very long time for that to come down, hundreds of thousands of years before it gets back down to pre-industrial. And so we're going to be warming the climate for thousands of years. So people in the year 3000, the year 4000, their climate will be determined by the decisions we make. Decisions we make will determine the climate for a very long time. And so we really don't have time to wait 40 or 50 years. It sounds like, if I remember your previous guest, he basically said something like, eventually we'll take care of this, but it's not a priority. I think future generations beg to differ on that. They're going to be affected by this for a very long time. And to me, that's one of the most challenging parts of this is the very long time scale of our impact.
Is there any potential for a technology that extracts carbon from the atmosphere?
Yeah, absolutely. People are working on that. So that's a big, they call it direct air capture. That's a big deal. It's expensive. It takes a lot of energy to do that. So in order to do that, you really have to think about the energy system and where that energy is going to come from. You don't want to burn coal to generate the energy to pull. That would just be this closed loop money losing system. So you need to think carefully about what you're doing. People talk about other things, fertilizing the ocean. Some people talk about trees. Trees, it turns out, I'm pro-tree. Let me be clear.
One step at a time. Fertilizing the ocean?
Sure. So, yes. So sometimes I get so excited about talking about this. I go 100 miles an hour.
I love it.
So in a lot of places in the ocean, it's nutrient limited. So in other words, the amount of algae that grow is limited by one certain nutrient. And in a lot of places, it's iron. So if you drive a cargo ship full of iron and you just dump it out the back, you could grow a lot of plankton. The plankton would suck carbon dioxide out of the atmosphere, and then they would die and they would sink.
So we could take potentially our iron waste and dump it into the ocean, and that would make all this plankton grow, and that would suck carbon dioxide out of the atmosphere?
That's the theory. I don't think anybody seriously talks about that, just because for a number of reasons. Mainly, we really don't know if it would work.
And how much iron would we need, and where would we get it?
Yeah, I'd be honest, I can't. I probably shouldn't have used that as an example because that's not something people seriously talk about.
Okay.
But that was just an example of other ideas that people have come up with in the past.
What are other ones?
Well, there was an article a couple years ago about trees, planting 1 trillion trees. It turns out that that's not a particularly good idea for a couple of reasons. First of all, and let me say I'm pro-tree. I'm not anti-tree.
That's a risky stance.
I know. It's
you're going out there. You're pro-tree?
I am pro-tree.
Are you a tree hugger?
Yes, I would hug a tree as long as it's, And so the problem with planting a lot of trees to pull carbon out of the atmosphere is that you need a lot of land. It's not clear where that land would come from. And then the biggest problem is a tree is not a good long-term storage for carbon because you have a forest, it grows up, and then the forest burns down. All that carbon's back in the atmosphere. And so you need to be able to store carbon for a very long time. So trees, even though I think we should be planting trees, I love trees, they're not a way to solve this problem.
One of the things that Stephen said when he was on the podcast was that the Earth is far greener now because of the fact that there's excess CO2 in the atmosphere.
Yeah, that's right. I mean, so we know that of the carbon that we've added to the atmosphere, 1/4 of it has gone into the biosphere. So 1/4 of the carbon we add goes into the biosphere. 1/4 goes into the ocean. So the stuff that goes in the ocean is acidifying the ocean. So that's ocean acidification. The 1/4 that goes into the land does green it.
But so there's a corresponding negative effect to all the greening. There's also, you have to think about acidifying the ocean at the same time. So with all the green, if you're saying 1/4 and 1/4, so that's literally half, right?
Yeah, so half the carbon we add doesn't stay in the atmosphere.
Gets absorbed by the ocean or by plants.
Exactly, yes.
And so if they did plant a massive amount of plants everywhere, it still wouldn't be enough.
Yeah, there's no, if there were an easy way to pull large amounts of carbon out of the atmosphere that way, we would be doing it.
Now, I don't remember where I saw this. I'm sure I saw it on the podcast. Jamie probably pulled it up, but I think it was in China. I forget where it was, where they had essentially a skyscraper-sized air filter that they were going to center in a city.
This is different, but this is similar.
World's biggest machine capturing carbon from the air turned on in Iceland. Operators say the Orca plant can suck 4,000 tons of CO2 out of the air every year and inject it deep into the ground to be mineralized. Is that a lot? 4,000 tons?
So last year, human emissions were probably 40 billion tons. So this is not meant to be a major.
No, it's not.
This is not meant to be a major. This is a sort of a proof of concept, is how I would look at it. So people are working on this, but you have to realize that to pull 10 billion tons of carbon out of the atmosphere in a year, which is probably kind of around the magnitude we'd have to do, that would be just a titanic industrial process. It would be equivalent to about all of the infrastructure we have to produce that much. So think about all of the wells, all the power plants, exactly. So it's certainly theoretically possible. It may be that we end up doing it, but I don't think we can rely on that. That is, you do not want to bet the farm or your kids' futures on that. I mean,
Jamie, there's an image right there. Click on that article. It says sucking carbon dioxide from air is cheaper than scientists thought. So this is from Nature. It says estimated cost of geoengineering technology to fight climate change has plunged since a 2011 analysis. Now, is it possible that, like all these other things, like you were talking about solar, how solar was far more expensive and the yield was far lower, 20 years ago, that as time and technology increases, they could get to a point where they could siphon this carbon dioxide from the atmosphere much more efficiently?
Yeah, just like when I was talking about batteries, there is so much money in this. If you could come up with a cheap way, if you could do this for $50 a ton, you would be richer than Croesus. I mean, you'd be the richest person in the world if you come up with a way to do that.
And carbon is valuable too, right? They could use it for things.
Yeah, you got to pump it underground. I mean,
really?
as long as you use it for some way, it's never going to escape.
Fuck up underground. What if you pump it in there and fuck that up too?
We know that these natural gas reservoirs where you'd put it, it stays there for a long time because natural gas has been there for millions of years. So I think we know how to drill. We know how to do that. That's pretty well understood.
Talk to me about fracking. Now, I saw that documentary, the Josh Fox documentary. I don't remember what it's called.
Is that one with the water on fire?
Yes,
right.
Yes. What is that valid? Like, what do you think is about fracking, and what are the issues that it causes?
I don't have a specific view of fracking compared to regular natural gas production, non-fracking natural gas. So we just got to stop doing it. I mean, all of it.
Just all natural gas production.
Yeah, I mean, over the next few decades, not tomorrow, but
right.
Natural gas, it failed during the Texas cold spell. And in Europe right now, natural gas is extremely expensive. And so remember how I talked about a grid has intermittence and it has to have dispatchable firm power. So if you go to the UK, their dispatchable firm power is natural gas. And when the wind goes down, which it's going to do, there are going to be periods where the wind's not generating. They have to turn natural gas. Natural gas is incredibly expensive right now. They are paying out the wazoo for it. We need to stop with commodity fuels. We should be going to nuclear, geothermal. I think geothermal is a dark horse. I actually think very highly of geothermal. Geothermal, if you go back 10 years, the issue was always in the drilling. But our drilling has gotten so good because of fracking, actually. The advances in the ability to drill.
How ironic.
Yeah.
Explain geothermal to me.
So geothermal is you extract heat from the ground. Then you use that
from lava? Like from what is?
Yeah, I mean, certainly in certain places like Iceland, for example, or California, there are places that's geothermal. They're actually pretty good at getting it not just from or they're getting better at getting it not just from these really high temperature places, but that's the traditional geothermal. You inject some water down, it gets really hot because of lava and just really hot rocks.
How deep do you have to go to do that?
I think thousands of feet. So it's
kind of miles or
1,000 feet's a mile.
5,000 feet's a mile, right?
Yeah.
Isn't that what it is? So they have to go deep into the ground where it's far hotter, and they take that and they use it sort of in a similar vein as nuclear power.
Yeah, or like any kind of conventional power. It goes down there, gets hot, it boils, and you get this really hot steam coming out, and use that to turn a turbine. That's kind of the traditional way. And people are working on all sorts of different things, using it in places where it doesn't get that hot, sort of lower temperature geothermal, and there's a lot of innovation going on in that space. So I think that's sort of the dark horse candidate. Instead of nuclear, maybe we could go with geothermal as dispatchable.
And then you don't have
power.
to worry about the fallout.
Yeah, you don't have to worry about all the known disadvantages of nuclear.
Now, fracking fracking is used for not just natural gas, but also oil, correct?
Yeah, so they get both out of these fracked wells. And in a lot of cases, they really care about the oil, and they just vent the natural gas to the atmosphere. Or they don't vent it. Sometimes they do, but they should flare it.
Light it on fire?
Yeah, light it on fire. So if you look at a satellite image of North Dakota from night, you can probably find one. You can actually see the fires, all these natural gas, all these wells flaring natural gas, and they just keep the oil.
But while they're doing that, they have to be doing some sort of damage to the atmosphere, right?
Oh, yeah. They're releasing a lot of carbon dioxide and fugitive methane, so not all the methane may burn.
That's interesting. You call it fugitive methane.
Yeah. And the other thing about it is it produces air pollution. You're burning methane, so
right.
you're getting crap blowing downwind. It's very noisy. If you've ever been near one of those, yeah. I mean, it's really, it's not good. I mean, wind and solar, by far, are socially better sources of energy.
So wind, solar, geothermal, and then potentially nuclear.
Yeah, I mean, in my mind, I kind of think about three different categories. You have wind and solar; those are your intermittents. You have some batteries that help you that are very short term, a couple hours, and that helps you shift solar energy from when you get it at noon to the evening. And then you have your firm dispatchable power, and it could be natural gas with carbon capture, although I think that is probably not where they capture the carbon dioxide before they vent it to the atmosphere. That has not been demonstrated to be something that we can do at scale yet. Then there's nuclear, there's geothermal, and then there's hydro. And if you live in a place where that's available, the geology is available.
Now, the use of petrochemicals and fossil fuel products has a bunch of different problems, and one of them is just the waste that's caused by the plastic, right. And how plastic is essentially, most of it is put into landfills. One of the things we found out doing this podcast is that most of the plastic that you think you're recycling doesn't really get recycled.
Yeah, that's very sad. And let me just say, when I say we should get off fossil fuels, I'm not talking about non-emissive, non-emitting processes like plastic. I think plastic plays a key role in our society. We do create too much. That's a whole different problem that needs to be solved. But I think it's perfectly consistent that we continue producing oil to produce plastics until we can find a way to solve that. I'm just really talking about generating energy with fossil fuels.
Isn't there potentially different kinds of plastics that can be created from alternative sources?
Yeah, you're way outside of what I know about.
Okay.
What I know scientifically. But
I think there's biodegradable plastics that are made from plant matter.
Yeah, no, I wouldn't be surprised at all. And
see if you Google. I think it's one of the problems with hemp being not illegal anymore, but it was for the longest time. Google plastic from hemp and whether or not it's scalable, because obviously there's you know who Boyan Slot is?
I don't.
He's a brilliant young man who devised a method to extract plastic from the ocean with these giant machines that sort of scoop plastic together out of the ocean, and they use it to create products. But that Pacific garbage patch, which is insane.
Yeah,
it's
no,
as big as the state of Texas, if not bigger, right?
It's depressing.
It's enormous. It's so crazy when you see how big it is, on a map, and that it's all waste, and it's all within the last 70, 80 years, right?
Yeah.
From the advent of petrochemical products.
Yeah, I mean, one day I worry that we're going to find out we've done something really terrible to sort of the ocean ecosystem, and that it's beginning to affect humans.
Uh-oh, here it goes. Despite claims about hemp plastic's ability to clean oceans and limit landfill growth, the truth is less universally positive. If current plastic consumption patterns persist, by 2050, the oceans will contain more plastic than fish by weight. Holy shit. According to World Economic Forum report, in the meantime, plastics will continue to leach into the human body And while scientists debate the certainty of toxicity studies determining that bisphenol A, BPA plastics are carcinogenic, the FDA will continue to review BPA safety, and of course plastic consumption will increase petroleum consumption, wreaking havoc on the environment and geopolitical stability. What about other things that affect our environment? One of the things that people always like to point to...
Crypto.
Is that bad? Or
well,
good?
I mean, they're using a lot of power
to generate crypto.
To generate crypto, and
I think decentralized currency would probably prevent a lot of the issues that we're dealing with monopolies and politicians, and the kind of fiat currency problems that we have. Don't you think?
One thing I've noticed about Bitcoin is it seems to mainly be used by Bitcoin bros. And by
don't point to me, man.
No, not you. But I mean, I did point to you. Sorry, I meant
easy.
Yeah, no, I meant
Jamie's a Bitcoin bro.
I meant Bitcoin bros are on the same family tree as nuclear bros.
Oh,
yeah.
Okay.
Mention Bitcoin on Twitter, and you will be inundated.
Yes.
And let me just be clear to anyone listening to this: I'm not mentioning Bitcoin, so you don't have to go to my Twitter feed. And it's also used by criminals. And so while I understand the allure of
they
Bitcoin,
also use all sorts of money.
Criminals
don't just
also
love
use
Bitcoin.
Houses and they drink water.
Yeah, but 99% of the houses are used by honest people, whereas with crypto, I think look, we probably don't want to talk about crypto. Let's I realize now that was a strategic mistake.
No worries. I know where we're going with this. So, but what I was getting to is there's a lot of other things that people point to as having a negative effect on the environment, and one of them is a big one that gets into the weeds ideologically is veganism. Vegan diets versus animal-based diets, and whether or not you can truly have renewable, like a farm that's a carbon-neutral farm that grows plants and animals and does so in this sort of symbiotic manner where you could feed large-scale populations, but it's a carbon-neutral environment.
Yeah, so you've opened a whole can of worms there. So what we've been talking about so far is just emissions from energy.
Yes.
And that is a pretty, in my view, and I think in the view of the people that work on this, is a solvable problem over the next few decades. We can solve that problem. When you get into agriculture is actually a huge source of emissions for climate.
Yeah.
And that is a much more difficult problem to solve. I'm not saying it's not solvable, but it's there's not, with energy, with power, there's a real clear path. We know the solutions, we know the technologies. It's really just a political problem. It's not as clear that with agriculture that, we're going to be able to do that as easily. And I think that a lot of it will end up being a political problem, but the agriculture sector exerts enormous power in our society. Why do you think we have ethanol blended into our gas? It's not because that's actually a good way to use corn. It comes from corn. They make ethanol and they blend in the gas. It's because, in this really weird quirk, Iowa is the first state that nominates president. So everybody who wants to be elected president has to go to Iowa and say, I'm in favor of blending ethanol into gas. I mean, that's why we have it. And Rick Perry, he would lambaste that all the time when he was governor of Texas. And then he ran for president, and all of a sudden he supported it. So you have these really weird political things going on in agriculture. It's very powerful politically. And so I do think that, that's something that we have to work on, getting our emissions down from agriculture.
Is there, have you ever studied this? Is there like a long-term solution to a viable carbon neutral farming system?
I'm not an expert in this, but I do think that there are methods of not just stopping emissions, but actually sequestering carbon in soils through various farming techniques and things like that. You just have to really convince farmers that it's in their interest to do it. And so you talk about, well, maybe we could pay farmers to pull carbon out of the atmosphere and things like that.
Well, the people that have talked to me about this that seem to think that there is a way to do this, they're doing on a very small scale relatively to, like, one of the problems morally and environmentally that we have with farming in this country is factory farming of animals, because it's horrific. Everybody's seen the videos, and it's like you know about the amount of waste that it causes and what it does to the environment, and also monocrop agriculture, because it's not normal to grow, thousands of acres of one particular kind of plant, and in order to do so, you have to kill everything else, including all the animals, all the different things that could possibly consume your crops, all the different bugs. You have to kill a lot of stuff.
Yeah, I mean, I think that you got to realize that our agricultural system is optimized for profit. Yeah, it's not optimized for anything else. And so factory farming is a way to produce the most pounds of hogs, per dollar you're spending. And if you want to do something different, people have to recognize that they're going to pay more at the grocery store, but you'll get these other benefits. You'll have less climate impacts. You'll have these moral benefits. And so I think as a general rule, we haven't done probably as good a job, and that's because there are people out there that are sort of combating us with misinformation, at really explaining all of the costs of our present economic system. As we talked about with fossil fuels, you're killing millions of people around the world every year from air pollution, and that's a huge cost, and all of the cost of climate change and things like that. And you just have to realize that people have to realize they might see higher prices for meat in the store, but there are benefits from that.
I mean, we could make the argument that you're killing millions of people with poor diets as well, and that the main contributors to this poor diet economy are probably fast food.
Yeah, no, that's absolutely right. And I do think that there's a lot of certainly that is a tremendous cost.
But the problem with that is kind of the same problem that we have with fossil fuels, is that people want to do what they want to do. They want to be able to go to Whataburger like you, sir. Look at you there, you guilty bastard.
I love Whataburger.
See, that's the problem. That is the problem. Not that
For the record, I was driving in.
Hey, for the record, that's what everybody says.
That's right.
That's what fast food's all about. You don't have time to pull over and bust out a hibachi and cook a steak.
That's right.
Yeah, and even if you did, who's growing that cow? And how's it being grown?
Yeah, that's exactly right.
Yeah, I mean, you got to go to some sort of a sustainable ranch and get some grass-fed, grass-finished beef on a free-range cattle where the manure is being recycled and they're using it and they're composting it, and then they're having pigs roam and chickens roam, and everything is sort of like feeding into the soil.
Yeah, so let me sort of talk about agriculture in general. I almost never talk about agriculture because I've talked to people who know a lot about it. And the thing I realize, it is incredibly complicated. Just, farmers, agricultural systems are one of the most tightly managed by humans. Of all the systems we have, that's the one that humans manage. And so there's a lot of capacity for adaptation, for people to adjust things. But nobody does anything if there's not a positive return on investment, if they're not going to make money from it. So really the challenge here is to convince people to do things that are good for the environment that make them money. A lot of farmers put wind turbines on their farms, not because they give a crap about renewable energy. They probably all hate Al Gore. They do it because they get paid. They get a monthly check for doing that. And so you can convince people to do the right thing if you financially incentivize them to do it.
And that's the key.
That is really the key. That's always the key. Money always talks. I mean, if there's one absolute truth in everything having to do with this problem, it's money talks.
But isn't that part of what the problem that got us to this position in the first place? Potentially with, like, when you're talking about growing corn, for instance, for ethanol, like one of the things that we do is we subsidize farmers to grow corn.
Oh, yeah. I mean, money talks got us into this. The fossil fuel companies want to make money, and, they do whatever they can to make money. If that means giving lots of money to politicians and supporting, dark money groups who run ads against their opponents, this is all stuff that, they're looking at their bottom line. They look at their job as to make the most money possible. And if you believe that's your job, and most corporations I think do, then you're willing to do anything to do that. You'll buy politicians because it's legal. It's completely legal to buy a politician in this country.
Now, when you look at the future, when you take into account all these issues, whether it's coal-fired power plants or fracking or agriculture, if you're being realistic, do you think we can turn this around?
Yeah, so keep it up, slide 11. So let me sort of lay out sort of our choices here. No, that's not it. 11, yeah, that's it. So this is a bar chart that kind of shows sort of our possible climate future. So the one on the left that goes to about 10 degrees Fahrenheit, that's the temperature change from an ice age. So I think we can all agree, if the Earth went into an ice age, that would be very bad. Can we agree on that?
I agree.
All right. So, and that's surprisingly, most people don't know that. That's only 10 degrees away. If we cool the planet by 10 degrees, we would have an ice age, and it would be an economic catastrophe. I mean, I can't.
Not just economic, right?
Yeah, absolutely. It'd be a catastrophe in every way, shape, or form.
We wouldn't be able to grow food. Yeah.
Right. And so we've already warmed about 2 degrees Fahrenheit. That's the green bar. So we're already 20% of the way to an ice age. Ice age amount of warming. We're going in the opposite direction, obviously. Ice age is down, but we're going up. 20% of an ice age amount of warming. Business as usual, that's BAU. That's about 5 degrees Fahrenheit. That's half of an ice age. Okay? So that should scare the crap out of you.
Half of an ice age.
Ice age in terms of temperature change, an ice age of warming. I look at that and I look at my kids and I think, holy crap, if this happens, I don't know how bad it's going to be, but half of an ice age of warming could be awful. I mean, really, Mad Max. Now, whether you want to take action on that actually is not a scientific question. Some people might look and go, Mad Max looks cool. I would love to live in Mad Max. And so they might not be worried about it. Some people might say humans will adapt. I have this infinite wisdom, confidence. Thank you. Infinite confidence in humanity that we'll figure out some way to do it. And I hate government regulation. So bring on the heat. But, I look at this, and again, I'm speaking as a citizen now, not as a scientist, but as a citizen, I don't have infinite confidence in humanity. I look at COVID, I look at the Texas blackout, and I think we're going to F this up.
When Koonin was talking about global warming and climate change, one of the things that he said was that what it will do is open up new areas for agriculture, and that agriculture will move steadily north, and that we'll adapt to that.
Yeah, so that's actually happening. So agriculture is moving. You can actually look at the average acre of corn that was grown, and it's actually moved about 150 kilometers north and to the west. So north and west is higher altitude, so to cooler regions. And that's actually right. So eventually agriculture will move into Canada. At some point, it's going to move as far north as it can move.
And this is over what period of time that it's moved 150 kilometers?
Probably a couple decades.
Mm-hmm. That's not a lot of time.
That's not.
A couple decades is pretty recent.
And we haven't seen that much warming. We've seen about a third of the business as usual warming. So agriculture, as I said before, agriculture is one of the most intensively managed and adaptable systems we have. So saying agriculture will be fine, that should not give you any reassurance. Let's talk about some other things.
Would it be easier if we just invaded Canada and took over?
Grow
our stuff up there if it gets too warm? Because I think we probably should invade anyway at this point.
Well,
they seem like they need our help.
They put gravy on fries. I'm not sure.
You never had gravy on fries?
I have not had.
You've never had poutine?
I have not had poutine. I'm not sure.
Oh my God! You should shut your mouth until you have it because it's amazing.
Fair enough.
How dare you?
Fair enough. All right, so let's talk a little bit about some other impacts because again, agriculture is the one I think is probably the most likely we'll be able to adapt as well as possible. Let's talk about something that's unadaptable. For example, permafrost melting. So, we're melting all this permafrost at the top of the world. How do you adapt to that? All of the stuff that was built in the north, they essentially build it on permafrost with the assumption the permafrost will never melt. So you build a house on permafrost, you say, okay, that's my foundation. And then the permafrost melts and the house splits.
When you say the north, what are you talking about? Where?
Oh, well, like anything, Alaska, Siberia.
They're building houses on permafrost up there?
Yeah, they put the foundation on the permafrost with the assumption the permafrost is never going to melt.
And it melts, then it'll soften, and then the houses will sink.
Exactly. The house just splits. It doesn't sink. It's, you have these, it becomes structurally uninhabitable. And that happens with roads. That happens with all this infrastructure. In addition, as you heat up the permafrost, it starts emitting greenhouse gases, things like methane, carbon dioxide.
I read that one of the big issues, they were talking about Siberia, and that as Siberia slowly melts, that it's going to emit an incredible amount of greenhouse gases.
Right. So that's certainly a possibility that scientists worry a lot about. And that's one of the worst case scenarios, because if that happens, then we lose the ability to stop climate change. Because even if we stop our emissions,
it's a cascade
it's what we call a feedback system. And so permafrost is one really hard to adapt to impact. And there's ocean acidification. How do you adapt to that? The oceans are more acidic. What are you going to do? And then there are the things that are extremely expensive. So imagine sea level rises. You've got to build these seawalls. You have to do it around Houston. You have to do it around New York. These are tens of billions of dollars. I mean, we're going to get to my worry is we're going to get to a situation where we're spending all of our money just trying to stay alive, building stormwater infrastructure to handle more severe rainfall, building seawalls, building, things to keep people alive when the temperature gets really hot, building new infrastructure for agriculture. Because remember, as the agriculture moves, the infrastructure has to move. All of your grain processing plants that were down here, you got to rebuild them up here. And so we're going to be spending all of our time and all of our money just trying to stay alive. You're not going to have money to buy, to buy a new iPhone or to go to college. It's all, because that money's all going to be tax money. I mean, that's where it's going to come from. And let me just add one thing, which I think is really important here. A lot of people are concerned about the freedom aspect of this, as I am. We saw with COVID that disasters often come with more government intervention in our lives. When COVID hits, you got to wear a mask, and in certain situations, you got to get vaccinated. And people don't like that, and I understand that. What do you think is going to happen if there's a food shortage? What do you think is going to happen if we have to relocate Miami? It's going to be massive government intervention. If you want to have a world where the government doesn't tell you what to do, we need to solve climate change now, because it's going to be a much larger infringement on our rights if society starts to fall apart.
Have you debated anyone about this?
So I have not debated anybody about this. Actually, I take it back. I debated this person, Richard Lindzen, in 2010. My feeling is that I won't debate the science. So the science is set. Earth, temperature's warming, humans are the cause. I'm happy to debate policy, because I think policy needs to be debated. So if someone wants to debate energy policy with me,
why wouldn't you debate the science?
Because the science has already been debated in the scientific system.
I understand that, but to the average person that gets confused and doesn't know whether or not you're correct or Steve Koonin is correct,
yeah. So I think
a debate would be very beneficial.
I disagree with that entirely, because
how so?
Because in a one-on-one debate, without the ability to fact check people, so let's
why
say,
couldn't you fact check them in real life?
In real time.
Yeah,
because, how do I do that? He says, this paper says this. And I'm saying, do you want me to read the paper?
Yeah.
Well, it would be a debate that would take a week.
So we'd do a week. I don't even think it would take a week, but there's certain points that you could get where you would go over them and we could kind of establish those points in advance. Like where's the contention? Like where's the disagreement? And why does he feel this way? And why do you feel this way? And I feel like if we established like a set of parameters or a set of areas of contention.
Well, we can certainly talk about that. I think we need to work that out. But let me just sort of finish what I was saying. That the scientific system of peer-reviewed papers followed by replication. Important results are always replicated by other people. That's how science determines what is right. And I feel strongly that. In the one debate I did do, I thought it was terrible and was a waste of my time, and I said I would never do that again. But policy is different. Policies are value judgments, and I think you do have to have public debates about that. So I think we do need to get out there and advocate for what we think we should do.
What he said is that he got into this because he brought a bunch of people together to discuss what the science is, and he said the science is not nearly as settled as he thought it was when he first started examining it, and that's why he wrote this book, and that's why he took a deep dive into the data.
That may well be true. I can't comment on why he did what he did.
Well, that is why he did what he did. That's what he said. But the point is, like, when someone hears him or when someone hears you, There's people that would hear you and go, well, this guy's not right because Steve Koonen's right. And I heard Steve Koonen say this. And then there's people that hear you and go, well, he's right and Steve Koonen is wrong because Steve Koonen left out all these different things and he was incorrect about that and he was way too lenient on the government when it comes to like this could be settled. At least it can be explained in a way that a rational person could have a more informed opinion of what's going on.
Yeah, I think you overestimate the ability to settle these issues in a debate. And I will say,
maybe
you're absolutely right. This is why tobacco companies hired scientists to go out and push them because they understand the power of a scientist saying, X is true, Y is not true, and so you're absolutely right. And it's going to be, it's very frustrating to me to hear someone like Dr. Koonen. And what's particularly irritating is, there's always this little bit of conspiracy in there about these people, they know the truth. They're afraid to say it. I mean, let me ask you, why would I be afraid? What do you think? What bad would happen to me if I came out?
Well, I don't think you're afraid at all.
Right, but
I do think that there are some people that agree with him that do not want to talk about it publicly. I'm not saying
but what are they afraid of? What are they afraid of?
They're afraid. Well, there's I think being called a climate science denier, being called a conspiracy theorist, being maligned for your opinions. I think that's a real thing in this day and age, don't you?
I think that certainly everybody gets pushback. I mean, I get a lot of pushback. I get hate emails.
Yeah, but you're on the right side of it.
But the point is, I'm still getting a lot of pushback. So the
everyone
pushback
gets pushback.
Right. So the pushback doesn't change. Yeah, you certainly know that. But Dr. Koonen is an example that you can have a great career taking his position. He's on the Joe Rogan show. I mean, how great is that? Yeah, but I mean, the point is, it's not
you're
like
here too. That's a bad argument.
No, but I'm saying is he still has a good career. Right. And in fact, the only reason I'm on is because he was on. You would not have had me on.
Of course I would have.
Well, all right.
That's not true. I definitely would have.
All right. Well,
listen, I don't know anything about climate science, so I would be more than. I did not have you on just because of that. I had you on certainly as a result of him being on,
right.
But I most certainly would have had you on anyway.
Right. Well, again, so we can talk about how to do it. I'd be open to discussions about sort of parameters. I think the thing you don't want to do. In fact, he even made this point, which I thought was actually an excellent point, which is. He's as worried about it as I was. He said, make people write down their views. I mean, that's what we do in the peer-reviewed literature. He said, I don't want to just have a debate. Make them write down their things and give citations and stuff. And, that's why you look in the peer-reviewed literature where people write stuff, it goes through peer review, then it gets published, and it's all written down. And it's much harder to get crackpot ideas out. I mean, I could say anything to you about anything, and, I could just say it, but if I have to write it down and give you references, it's much harder to do that.
Right.
But I do think public debates about policy are really good. We need to have people talk about, what's the pros and cons of this or this.
My take on what you're saying is there's certain things that you're saying that are irrefutable. First of all, the particulate matter in the air that's caused by power plants that are fueled by coal, and we look at that video from Evansville, that's horrific to me.
Yes.
All that stuff's horrific. This the idea that the only way we can move forward is by continuing to do what we're doing already, and fossil fuels and all that jazz, like that doesn't make any sense to me. And I do hope that there is some innovation when it comes to battery construction methods and efficiency and all that jazz, and that we do move away from a lot of the stuff that we're doing right now. I wish it was. I wish there was no gray area. I wish there was no legitimate, intelligent people that thought differently. That's where it gets confusing, because I feel like I read his book and it was pretty fascinating. I've read several things where you rebutted him, and I've read several things where you stated your position. So I was very excited to talk to you about this. And like I said, there's many things that you're saying that I don't think anybody can refute, particularly the effect of using these things that's happening, not just in terms of warming, but in terms of pollution.
Yeah, you have to look at the whole menu of disadvantages. And if you do that, you realize we really should be phasing out fossil fuels as fast as possible.
And we really should be taking into account what's happening with these increased levels of pollutants in our atmosphere, and this is not very simple. You know, I get very upset when we were talking about that. What is that Josh Fox movie called? What the hell is it called? The fracking movie, Frack Nation or some shit. What is it called? Remember? But I've heard people dismiss Gasland. I've heard people dismiss that and dismiss the impact that it has. I'm like, but how can you dismiss the fact that some people have water that you can't drink anymore? Like, what? How is that a dismissible thing? How if they're doing something that produces a significant amount of energy, but also pollutes water to the point where it can't be digested anymore? You can't just only look at one aspect of that. You can't only look at the market. Oh, so these people have to move out of their farm. Well, they paid them off. But where's that water going? Like, where's that polluted water going? What kind of an effect does it have on the animals? What kind of effect does it have on the plant life? What is it leaking into the atmosphere? Like, what's happening? And how long does it take before we know what's happening? Is this something that's real simple that you can, cut it off right there and then there's no more damage done? Or is this something that leaches out into our environment for decades or hundreds of years to come?
Yeah, and I mean, you make a lot of good points. There's the impacts, especially on people of modest means who are significantly impacted. Corporations just don't have to worry about that. And, so if you live next to it, there are lots of stories about people who live near these big industrial plants and suffer really horrific cancers and other problems. And it's as time goes on, it becomes harder and harder for people like that to get some sort of compensation or to get the harms addressed. I mean, I do firmly believe, and I think this is a key thing about climate and everything else, that polluters should be accountable for the damage they pay. And so the people who are spewing fossil fuel effluents, carbon dioxide and methane into the atmosphere, they should be held accountable for that. And right now they're not. And that actually is the core of the problem. If they were actually being held accountable, fossil fuels would be gone very quickly.
Because it wouldn't be profitable.
Exactly. It'd be non-economic. And so what you're talking about is, what economists call externalities, which are costs imposed on people who are outside of your transaction. And that's really the problem. That there are these free, you can throw, it's like you walk over to your fence, you throw your trash in your neighbor's yard. If you can do that for free, why wouldn't you?
Right.
But you can't do it because your neighbor will get mad and, but that's essentially what a lot of corporations are doing right now. And we let them get away with it because they are so politically powerful. They've gotten to the point where they're more powerful than any non-corporate entity. They're more powerful than the people.
I think that's a great point, and I think that's a good way to end this. Is there anywhere online? Could you direct people online to what's the best place to see your work? And
my SoundCloud. No, I don't know. I do not have a SoundCloud.
Is that one of the dad jokes your kids warn you about?
Yes, that is one of my dad jokes.
You should be rapping about climate change. Maybe you could be on TikTok.
There's a climate change rapper who's actually quite good.
Really?
Yeah, I would say
I doubt that's true.
I'd say if people want to see me, they should follow me on Twitter, Andrew Dessler. I'm always tweeting about climate.
Spell that, please.
ANDREWDESSLER, one word.
Okay.
And
on Twitter, and do you have an Instagram as well?
I do not have an Instagram.
Okay, good for you.
Yeah.
Well, thank you very much for coming here. I really appreciate it.
Oh, it's been great. I really enjoyed it.
I enjoyed it too. It was very enlightening, and I think it helped a lot. It helped to balance things out.
All right, good.
Thank you.
And hopefully I'll talk to you again someday.
Yes. Well, hopefully he'll respond, and maybe we could get something together.
Okay, good.
I think it would be very enlightening for people. I really do. I think it would help a lot.
Okay, good.
Thank you. Appreciate you.
Thank you.
Bye, everybody.